Hi everyone, welcome to goclasses. In this lecture, we will continue our discussion of liveness analysis or live variable analysis. So this is live variable analysis part 2. In this part, we will study one application of liveness analysis, that is dead code elimination. So let's start. You can find part 1, the liveness analysis, the complete lecture you can find on YouTube. You can search on YouTube liveness analysis go classes on YouTube. You can search. Okay, you will find this video. In this video, I have covered the complete liveness, the live variable analysis, all the concepts, terminology, a lot of practice questions we have done in this lecture. You can watch it. You can find the link in the description. Now, so we were discussing liveness analysis or live variable analysis. Remember, this live variable analysis, this is just an analysis of the source program. We have our source program, or I can say intermediate program basically, because this is intermediate optimization we are discussing, intermediate code optimization. So we have our intermediate representation, and on that intermediate representation, we apply this liveness, live variable analysis we apply, so to get some insights about the intermediate representation. Okay, so this intermediate representation, on this representation we apply the analysis to get some insights, to get some information about the intermediate representation. Then remember, based on this analysis, we can perform two type of optimizations. These are two type of very important optimizations which are based on live variable analysis. So these are the applications of live variable analysis. These are dead code elimination and register allocation. In this lecture, we will study dead code elimination. In the next lecture, we will also discuss register allocation with all the gate PYQs. Now, in the previous lecture, we were discussing this live variable analysis, and first we were discussing this liveness analysis we have already discussed for individual statements. So first, for the individual statement, we have seen how to do the live variable analysis. Then for basic block, we have seen how to do the liveness analysis. Then we were discussing control flow graph. For CFG, how to do the liveness analysis. This is what we were discussing. We have already seen how to do liveness analysis for CFG without loop. A lot of practice also we have done. In this lecture, we will do the practice of liveness analysis for CFG with loop. Okay, we will take some questions where we have control flow graph with loop, and for this type of CFG with loop, we will do the liveness analysis. Okay, remember these three, for the individual statement, for basic block, and for CFG without loop. For these three liveness analysis we have already discussed in the previous lecture. You can search on YouTube, or you can find the link in the description. Okay, so for this lecture, first we will discuss liveness analysis, live variable analysis for CFG with loop. Okay, let's start. So in the previous lecture, when we were discussing live variable analysis for CFG, so there are two cases: CFG without loop, CFG with loop. For CFG without loop, I told you that how to do the liveness analysis. It is very simple. In the backward direction, a single pass is enough. Okay, basically go from the backward direction. From the exit node you start, and you just keep going in the backward direction. A single pass is enough when you have CFG, control flow graph without loop. Okay, now when you have control flow graph with loop, then how to do the liveness analysis? The concept is very simple, similar to the CFG without loop. So basically we will go in the backward direction. But remember, when we have CFG with loop, then if you are doing the analysis in the in the reverse direction, in the backward direction, then also multiple passes might be needed. It might be possible that we need to do multiple passes of liveness analysis. Okay, until no changes happen in the liveness information. If no changes happen, then we can stop. Otherwise, we need to do multiple passes. Okay, very simple. Now, I also told you one tip. When we are doing live variable analysis for CFG, for control flow graph, then consider this tip. This is very important to save a lot of time. So basically, in the backward direction, when we are doing this liveness analysis, then remember, instead of going statement after statement, we will go basic block by basic block. Okay, in the previous lecture, we have already seen how to handle live variable analysis of a basic block. So we can handle a particular basic block, a single basic block we can easily handle. So I can say what we will do, instead of going statement by statement in the backward direction, we will go basic block after basic block. For the entire basic block, we will find these two set of variables, use b and def b. Use b, that is same as gen b, means which variables are generated by this basic block, and def b, this is same as kill b, means which variables are killed, or I can say which variables are defined or which variables are assigned by this basic block. Very simple. Okay, so you can see for the entire basic block we will find use b and def b, these two set of variables we will find, and then we will treat the entire basic block like a single statement, like we have already seen in the previous lecture. Okay, now before we discuss CFG with loop, let me take one example of CFG without loop. Already in the previous lecture, we have done a lot of practice of live variable analysis on a CFG without loop. But let's take one example. Then we will go to CFG with loop. Okay. So consider this question. We have a control flow graph without loop. You can see there is no loop here. And we need to perform the live variable analysis. In this question, you can notice the question is saying that assume ABC are visible outside the method. Remember, method means function. I told you that for each function we create control flow graph. In your program, if there are 10 functions, then we create 10 control flow graph. Okay, and you can see this statement is saying that assume variable ABC are visible outside the method. Maybe the variable ABC, maybe they are used in some other method in the program. Okay, so what this line means, this line simply means that ABC are live on the exit. Okay, it simply means, this statement simply means that on the exit these variables are alive. Okay, so this is given to you, this information is given to us, that so you can see that here these variables are alive. I can say A, B, C, these variables are alive on the exit. Okay, this information is given to us. You can see this is what these two statement, that assume ABC are visible outside method, so they are live on the exit. Okay, this information is given that on the exit these variables are alive. Next, you can see assume x, y, z, t, these variables are not visible, means they are not alive at the exit. Okay, only these variables are alive at the exit. Next, you can see represent the liveness analysis using a bit vector. Basically, I told you in the previous lecture also how to represent live variable analysis, liveness analysis, or the liveness information, how to represent it using bit vector. The order is A, B, C, X, Y, Z, T. Remember, in the bit vector, when we represent liveness information using bit vector, then remember, if a variable is dead, we represent by 0. And if a variable is alive, then we represent by 1. Okay, very simple. In the previous lecture also, we have seen this type of question where we are representing liveness information using a bit vector. Okay, this is the order, you can see A, B, C, X, Y, Z, T. Okay, now let's perform the liveness analysis here. Okay, let me call this basic block B0 or B1. Let me call it B1, let me call it B2, let me call it B3. So in this question, what information is given to us? You can see out of B3 is given to us. Okay, in this question, you can see that out live of B3 means the set of variables that are alive at the exit of B3. Okay, so you can see at the exit of B3, at the exit point of B3, the set of variables that are alive, that is A, B, C. Okay, so you can see out of B3, that is A, B, C, and this information, remember, this is given to us. If they do not give us that which variables are alive at the exit, if they do not give us, then we will assume that no variable is alive at the exit. Then we will assume that this out of B3, this is empty set. But here it is already given that at the exit ABC are alive. Okay, so this information is given to us out of B3, that is ABC. These variables are alive. Very simple. Now let's perform the liveness analysis. Here you can see this is a control flow graph CFG without loop. So what we will do, we will go in the backward direction, a single pass is enough. Okay, so as you can see, this is b1, this is b2, and this is b3. And already this information you can see, out of b3, that is abc, abc are already alive here. This information is given to us. Now remember, here also I can say that the bit vector representation, what that will be, I can say at the exit point of b3, abc are alive. So tell me, this information I can represent using bit vector. How to represent using bit vector? Very simple. The order is ABC X Y Z T. Okay, so you can see, because ABC are alive here, so I can say that is 111, and X Y Z T, these are not alive, so I can say 0000. Is this point clear? So I can say that this is the liveness information at the exit node, or I can say at the exit point of basic block B3. I hope you understood. Okay. Now let me tell you that I told you that instead of doing statement by statement, here you can notice in this basic block there is only one statement. Here also there is only one statement. So these are very easy. But here you can see there are four statements. So if you go in the backward direction and if you do statement by statement, first this, then this, then this, then this, it will consume a lot of time. And if there is a CFG with loop, then it will take much more time. So remember, instead of going statement by statement, you always go basic block by basic block. This is what I told you in the previous lecture also. A lot of practice also we have done. Okay, so here what I will do, for every basic block, only one information matters. That is, what is the use set and what is the def set. Okay, yes or no? So remember, in this question, what you can do, every basic block you can convert into a single information. That single information is that in that basic block, for example, in the basic block B1, which set of variables are killed and which set of variables are used. Okay, so I can say which set of variables are killed. Killed means def, which set of variables are defined, and which set of variables are used. Used means which set of variables are generated. Okay, only this information matters to us. We do not care about 4 statement, 5 statement, 10 statement, 20 statement in this basic block. I don't care. For this basic block, we will find the set of variables which are killed by this basic block, or I can say the set of variables which are defined, which are assigned by this basic block, and the set of variables which are used before they are assigned. So the set of variables that are generated by this basic block, this is what I need to find. Okay, so you tell me, by this basic block, which set of variables are defined? That is very easy. That is ATCX. Okay, nothing here. So you can see ATCX. You just look at all the variables which have been assigned in this basic block. Okay, so you can see, sorry, don't consider X. Okay, this is important point, that don't consider X here. Why? What is the reason? Because you can notice that this is not assignment operator. Look at this operator. This is not assignment operator. This is equality checking operator. Okay, please take care of this. This is not assignment. This is equality checking. We are checking if X is equal to 0 or not. Yes or no? This is not assignment. This is not assignment. Okay, remember, assignment operator is something like this, that if you are, for example, in M you are assigning N. Here this is assignment, that the value of N you are putting in M. Okay, very simple. If N is equal to 4, then M also become 4. But here remember, if I have like this, equal equal, now remember, please understand, this is not assignment. This is, we are checking the equality. Is M equal to N or not? Here we are checking, is M equal to N or not? Okay, so here we check only the equality here. This is not the assignment operator. So this is an important point. This will make difference. Okay, remember, here you can notice that this is X equal 0 means, is X equal to 0? If yes, maybe, okay, if yes, then go to here, and if no, then go here. Basically, this is a branch instruction. Okay, please understand that this is a branch instruction. This is not some assignment instruction. Here you can see we are basically taking branches. It's something like this, that okay, it might be something like this, that if x is equal to 0, if the value of x is 0, then go to something something. Okay, yes or no? Like if x is equal to 0, if the value of x is equal to 0, then you go here. If x is not equal to 0, go here. So remember, it is not a assignment operator, I can say. Okay, very simple point. I hope you understood. Now, so here you can see that which variables are defined. You can see this is assignment operator, this is assignment operator, this is assignment operator. So I can say that ATC, these are assigned or defined or killed. Okay, but remember, X is used. Here you can notice X is actually used. Okay, so very simple. Let's see which variables are used. You can notice when you are standing here, then you can easily see that which variables are used before they are defined. For example, you can see A is used, but before A is used, it is defined. So I can say in this basic block, A is not used. Okay, when I say the use set for a basic block, when you are finding which variables are used in a basic block, then always remember which variables are used before they are defined. You can notice variable A is here also. We are using variable A in this second statement, but in the first statement, A is already defined. So remember, before A is used, A is already assigned or A is defined. So I can say in this basic block, we do not use A. I hope you understood. Or I can say that A is not generated by this basic block. Okay. But you can see X comma Y, they are used before they are defined. So X comma Y, they are used before they are defined. Next, you can notice A is not used before it is defined. Next, you can see what about T? T is not used at all. Okay. And you can see here X is used before it is defined, but that we have already taken from here. So that's it. Okay. Yes or no? That's it. Very simple. So I can say that only X comma Y, only they are defined in this basic block B1. Now let's see what about basic block B2. In B2, there is only one statement. So which variables are defined, which variables are used? Let's see. In this basic block B2, you can see T comma Z, they are used before they are defined. You can see. And this B, this is defined. Okay, so I can say B is defined, and T comma Z, they are used before they are defined. Okay, and you can see we have B3 also. There is another basic block, that is B3. In this B3, which variables are defined? Defined means killed. And which variables are used? Let's see. So you can see that C is killed, C is defined, and Y is used. Okay, very simple. That's it. So now you can see that we have converted every basic block into a single information that we need. Okay, only this information we need. You can see this is B2 and this is B3. And already this is given to us that here at the exit ABC, these are alive. Okay, and you can see these are the edges. Okay, so you can see these are the edges. That's it. Now you can easily solve this question. So tell me, already this out of B3 is given to us. You can see this is the out of B3, the set of variables alive at the exit of B3. This is given to us. So tell me, what will be in of B3? Can you calculate? Can we find what will be in of B3? What that will be? You can see that first you kill, then you use, then you generate. Yes or no? First you kill, then you generate. Very simple. Here, this is generate. Use and generate both are same. Kill and define both are same. So you can see that from this ABC, first this basic block B3, when you go in the river direction, we are going in the river direction. Okay, we will go in the river direction. So you can see that this block B3, this basic block B3, what it will do in the river direction when you are passing through, when you are passing this B3, first it will kill C. So C is killed. Then it will generate Y. So you can see ABY. That is your set of variables which is alive at the entry point of B3. So this is your in of B3. Very simple. Yes or no? That's it. Now tell me, after this block B3, can you go to B1? No, you cannot go to B1 because this B1 has two successor. To find out of B1, we need in of B2 also. we need in of B3 also. Already we have in of B3. So let's find in of B2. First, you tell me what is out of B2. Let me know what is out of B2. You can see that this B2 has only one successor. For B2, there is only one successor, that is B3. So I told you that out of B2, that is same as in of B3. Okay, so remember out of B2, that is ABY. Very simple. Okay. Now tell me what is in of B2. For B2, what will be in of B2? At the entry point of basic block B2, which set of variables is alive? So tell me. You can see that out of B2, that is ABY. Now in the reverse direction, when you cross this B2, then first it will kill B. First this B will be killed. Then TZ will be generated. So finally it will be AYTZ. Okay. AYTZ. Very simple. I hope you understood. Now you can notice, now we have in of B2 also, in of B3 also. And for this basic block B1, there are two successor. That is that is B2 and B3. So you can see that here I can say what is out of B1. Out of B1, that will be union of in of successor basic blocks. You can see the successors are B2 and B3. So you take union of in of successor basic blocks. Okay. So what it will become, you can see AYTZ, ABY. So it will become ABYTZ. This is what it will become. And finally, let's find what will be in of B1. What this will become? In of B1. So very easily you can find in of B1 when you go in the reverse direction. Then you can see already out of B1 we have, that is ABYTZ. Then from it, first you kill ATC. ATC will be killed. A, T, and there is no C. So AT will be killed. Okay. AT are killed. C also will be killed, but there is no C in the out of B1. Okay. So I can say that AT, these are killed. What is remaining? BYZ. Now you generate XY. Okay. So finally, what you will get? You can see you will get B. A, T are already killed. B, Y, Z, and XY are generated. So that is X. That's it. This is your final answer. If the question asks you what is in of B1, you can easily say the answer is BYZX. Okay. In terms of bit vector, how to write it? You can see the order. The order is ABC XYZT. Okay. So in terms of bit vector, I will say ABC. A, B, then C is not alive. So 0, ABC XY ZT. Okay, this will be the bit vector. I can say this is the bit vector for B1 bit in of B1 bit vector. I can say in of B1 bit vector. Okay, is this clear? What about in of B3 bit vector? You can see AB. So that is 1 1. C 0. There is no C here. In of B3. ABC XYZT. XYZT. Okay, very simple. What about in of B2? What about in of B2? Here you can see A, B, C, X, Y, Z, T. Okay, yes or no? X, Y, Z, T. This is the order. So very simple. I hope you understood this point. Okay. And at the end, you already know A, B, C, X, Y, Z, T. This is given to us. Okay. I hope you understood everything. Okay. You can see what is out of B1. What is out of B1, that also we can write A, B, C, X, Y, Z, T. Okay, these are the bit vectors. I hope you understood. Okay, is this clear? Very simple question. We have done the complete analysis of this question. Now let me tell you one more thing. See, in the question, if they ask you what is in of B1, or if they ask you what is in of B2 or out of B1, okay, basically if they ask you at the entry or exit point of the basic blocks, then you can do how we have already done. Okay, basically If the question is interested only in the entry or exit of the basic blocks, only in these points, if the question is interested, then we can convert every basic block to a single piece of information, and then we can solve like we have already done. But tell me a very simple thing. If the question is interested somewhere here, like what is the bit vector here at this program point, means between these two instructions there is a program point. Okay, so tell me at this program point what is the bit vector, at this program point what is the bit vector. Basically, if the question is interested between two instructions, what is the set of live variables. Okay, between two instructions there is program point. At that program point, what is the liveness information? If this is what the question asks, then you need to go statement by statement. Then you cannot go basic block by basic block. Okay, is this clear? So let's do statement by statement analysis also. Okay, now I am going to do statement by statement analysis, because maybe sometimes in the gate exam maybe they can ask you that between two instructions what is the liveness information. Okay, so let's do statement by statement analysis. Okay, let's find. Again, it is very simple, because we are going statement by statement. We do not have to convert, we do not have to find the use and def for a basic block. Okay, we do not have to do that. This is b1, this is b2, this is b3, these are the basic blocks. Okay, so you can see already here abc, this is the set of variables that are alive at the exit of b3. Okay, this is given to us. Now what we need to do, we need to do the statement by statement analysis. Okay, so let's go in the reverse direction. Let me also write the bit vector. Here you can see the bit vector is ABC XYZ T. This is the order. So I can say 1 1 1 0 0 0 0. Okay, this is the bit vector. Now tell me, for this instruction, there are two program points. One is after this instruction and one is immediately before this instruction. Yes or no? For every instruction, I told you there are two program points. One immediately before that instruction, one immediately after that instruction. Okay, so I can say that this information, this is basically out of this instruction. If you call it, for example, I1, I2, I3, I4, I5, I6. Okay, for a moment, if you call it I6, let's assume this is instruction I6. Okay, let's assume this is instruction I6. Then remember, this information that we have, this is basically out I6. Means immediately after this instruction I6, what are the set of variables that are alive. Okay, so you can see this is the out of I6. So tell me what will be in of I6. Tell me. Remember one more thing. This I6, this is the first instruction of basic block B3. So in of I6, that also will be in of B3. Similarly, remember, this instruction is last instruction of basic block B3. So remember, out of I6, that is same as out of B3. All these points we have seen in the previous lecture. I'm just revising all those points. Okay. Now you can see what is in of I6, that is same as in of B3, because this I6 is the first instruction of basic block B3. Okay, so tell me what will be in of I6. That will be which variables are alive when you cross this I6 instruction in the reverse direction. Okay, we are going in the reverse direction. The live variable analysis we perform in the backward direction. So you can see here that this C will be killed. First you kill, then you generate. Okay, so you can notice this is the assignment to C, or I can say this is the definition of C. So first you kill C. Okay, so first this C will be killed. Then you generate Y. Okay, so it will become A, B, Y. And of course, if you want to write the bit vector, that will be A, B, C, X, Y, Z, T. This will be the bit vector. Okay, understood? Now tell me, what will be out of B2, or I can say out of I5, because in this B2 there is only one instruction. So this is the first and last instruction of B2. So remember, out of B2 that is same as out of I5, and in of B2 that is same as in of I5. Okay, so I can say, let's assume this is for a moment, let's assume this is I5 instruction I5, then very simple point here. I can say for this instruction, what I can say at this program point, I can say that this out of I5, that is same as out of B2, and also in of B2, that is same as in of I5. Okay, very simple. I hope you understood. So out of B2, or I can say out of I5, that we have already found, that is in of B2, because remember here in of B3, because remember here that for this basic block B2 there is only one successor, that is B3. So the out of B2 will be same as in of B3, okay, because there is only one successor for B2. So that is the reason I can say that here also A, B, Y, these are alive. Okay, so tell me what will be in of B2? What is the set of variables that are alive at the entry point of B2? Very simple. This is the out of B2. So first you kill. Remember, this B will be killed. So first you kill this B. Then TZ you generate. So AYTZ. Okay, so this will be AYTZ. Very simple. Okay. So tell me what will be the bit vector for this? Bit vector will be A, B, C, X, Y, Z, T. This will be the bit vector. Very simple. Okay. Now you can see what will be out of B1. That will be union of in of the successor blocks. Okay. Because there are two successor for B1. So you take the union. Okay. So we will take the union, and finally that union, what it will become? It will become AYZT union ABY. Okay. So it will be, this union will become ABYZT. Okay, this is what it will become, and in the bit vector it will be ABCXYZT. Okay, that's it. Now you tell me what about here? Tell me what about here? What will be the bit vector for liveness information at this program point, means between these two instructions? Okay, here notice one thing, that here we are not writing X, here we are using X. Okay, yes or no? We are using X, not writing X. Please understand. Here we are using X. Okay, so because we are using X here, so what we are going to do, and remember, in this instruction, we are not defining any variable, we are not killing any variable, we are simply using X. Okay, so I can say that first you kill, but there is nothing to kill in this instruction. By this instruction, no variable will be killed. So simply you generate. So it will be A, B, Y, Z, T, and X. Okay, so it will be A, B, Y, Z, T, X. This is what it will become. Okay, and in terms of bit vector, what this will become? You can see bit vector will be A, B, C, X, Y, Z, T. This is what the bit vector will become. Very simple. Okay, and tell me about this point. Now you can see in the reverse direction we are going. Okay, we are going in the reverse direction. In the reverse direction, when you cross this statement, then remember, first you kill C. First C will be killed, then AX will be generated. Already there is no C, so nothing will be killed, and I can say that this AX will be generated. So again you can see that we will get the same bit vector 1101111. This is the bit vector we will get. Tell me about the bit vector here. You can see in the reverse direction, when you cross this statement here, you can see we are defining T. So first you kill T, and then you generate A. Okay, so very simple. First you kill T, then you generate A. Okay, so already A is there. Okay, so I can say it will be A, B, C, X, Y, Z, T. T will be killed. First you kill T, then you generate A, and that's it. Finally, here you can see when you cross this instruction here, A will be killed, and then XY will be generated. A will be killed, then you can see that x comma y will be generated. This will be your answer. I hope you understood. So this is the complete analysis of this question. You can find the answer here. Okay, I have told you, between every instruction also, between two instructions also, there are program points. For those program points also, we have found the liveness information. Also, we have found the liveness information for entry and exit point of the basic blocks. Here you can notice, here the question is only interested in the entry and exit point of the basic blocks. So for that, you don't have to go instruction by instruction. You don't have to do that. Okay, you can just find the def and use information for every basic block. Then you can treat the entire basic block like a single statement, and then you can go in the backward direction. And because this is a CFG without loop, so a single pass of the backward direction is enough. Okay, so this is the complete analysis of this question. If they ask you question about program points between two instructions, then this is the complete analysis. Okay, this is how you can do if you go statement by statement. And we have already seen how to do when we go basic block by basic block. Okay, so this is the complete analysis. I hope you understood. Now let's move on. Now we will consider CFG with loop, control flow graph with loop. You can see in this example, there is a loop. You can notice that there is a loop. Yes or no? Here you can see like there is a loop. Okay, so this type of loop is there. So this is a CFG with loop, and we will do the liveness analysis, live variable analysis for this CFG with loop. Already we have seen liveness analysis for CFG without loop. For CFG without loop, in the backward direction, you can do the liveness analysis. A single pass is enough. For CFG with loop, what will change? What are the changes? Nothing much. In the backward direction, we will do the liveness analysis. This live variable analysis, this is a backward direction analysis. So we will go in the backward direction, but multiple passes might be required. Okay, when you have CFG without loop, if you are going in the backward direction, a single pass is enough if you are going in the backward direction. But for CFG with loop, multiple passes might be needed. Very simple. Okay, until no change happens. So we will do multiple passes of the backward direction liveness analysis, and we need to perform this liveness analysis until no changes happen. So multiple passes might be required. Now there is an important point. When you have CFG with loop, then, so you can see for CFG with loop, initially we will assume that all the basic blocks have in of b equal to empty set. See, this assumption we don't have to make for CFG without loop. Let me tell you the reason why we need to make this assumption for CFG with loop. When we have CFG with loop, then initially we will assume that all the basic blocks have in of b, the set of variables that are alive at the entry point of the basic block. So that is empty. This is what we will assume initially. Okay. Why this assumption we have to make? This assumption we have to make because when you have CFG with a loop, then it is not clear what is the starting point, what is the ending point, because remember, this is a loop. Okay, so every basic block is dependent on every other basic block. It might be possible. For example, here you can notice in the loop, all the four basic blocks are there. Okay, if this loop is not there, then it is very clear this is the starting point. After this basic block, you will go here or here. Then after this basic block, you will go here. After this basic block, you will go here. And from this basic block, we will go to exit. But when there is a loop, here you can see there is a loop. When there is a loop, then every basic block might be dependent on every other basic block. Okay, yes or no? So you can see the entry and exit points, these are not very clear when you have CFG without loop. So that is the reason when you have CFG with loop. Okay, so that is the reason. Remember, for CFG with loop, initially we will assume that all the basic blocks have in of b equal to empty set. And this information, this paragraph is written in the Stanford also. You can read this, that when you have CFG with loop, you can notice when we do live variable analysis for CFG with loop, then remember every basic block might be dependent on every other basic block. To fix this, what we need to do, we need to assign initial values to all the basic blocks of the CFG. This is written in the Stanford slide, you can see. Okay, and what that initial value will be? We need to assign initial value to all the basic blocks, and that initial value will be empty set 5. Okay, very simple. So you can see we have this example where we have CFG with loop, and already this is given to us that at the exit only variable a is alive. This information is given in the question that at the exit this variable a is alive. What might be the reason? Can you tell me? At the exit of a control flow graph, how can some variable be alive? Because when we say that this variable is alive, it simply means it is used somewhere before it is defined. It is used somewhere. So tell me, at the exit of a basic block, how is it possible that some variable might be allowed? Some variable. Then tell me, how is it possible that at the exit of a control flow graph, some variable might be alive? Is it, how is it possible? Very simple. I told you that this CFG we make for every function. In your program, if there are 10 function, we make 10 CFG. So maybe this variable, this is used in some other method, some other function. Okay, so that might be the reason. So very simple. This is given that at the exit node, at the exit of this CFG, only variable a is alive. Okay. Now you can see, let's do the liveness analysis of this CFG with loop. The first step, let me tell you, very important. The first step is that for every basic block, you assume that in of b is equal to 5. Okay, you mention that for every basic block, in of b is equal to 5. So you can see this is the first step, initialization. Okay, you can see. Very simple. For every basic block, you assume, or I can say you mention, you initialize that the in of b is equal to 5. Now we will start. Now remember the liveness analysis, that is similar to how we do for CFG without loop. But the only point is that it might be possible that we need to make multiple passes. Only that is the difference. There is no other difference. We will do the liveness analysis now. So let's start. Here you can see we will go in the backward direction. Okay, let me call this basic block B1. Let me call this basic block B2, B3, B4. Okay, and this is the exit node. Now, as I told you when we were discussing CFG without loop, there also I told you that instead of going statement by statement, we will go basic block by basic block. So for every basic block, we will find what are the use and def. Okay, and only that information is required for us. Okay, so remember here in this basic block there are two statements, but I don't care about the number of statements. There can be 10 statements. I don't care. I only care about which variables are generated by this basic block and which variables are killed. Okay, so let's find for this basic block B1. Tell me which variables are killed. Killed means def. Okay, means which variables are defined. And you tell me which variables are used. Used means generated. Okay, so let's see. In this basic block B1, which variables are defined means which variables are assigned. You can see B comma C, these are assigned. Okay, so I will say that B comma C, these variables are killed by this basic block B1. That's it. Very simple. Okay, and let's see which variables are generated by B1. So you check which variables are used before they are defined. You can see C is used before it is defined, D is used before it is defined. Okay, so only C comma D, they are used before they are defined in this basic block B1. C comma D. Okay, C comma D. Notice one thing, that here C is defined, but before that C is used. That is the reason I can say that this variable C, this is actually used before it is defined. Also, you can see in this statement, you can notice we are using C, also we are defining C. So which thing happens first? Do we first use C or do we first define C? We first use C, yes or no? First we use C, then we calculate C plus D, then we assign to C. So please understand, in this statement also, first we are using C, then we are defining C. So this C we are using before it is defined. Okay, very simple. So you can see C comma D, these are generated by the basic block B1. Let's find for basic block B2. Only this information we care. Which variables are killed, which variables are used. So by the basic block b2 ad, these variables are killed. Okay, yes or no, a comma d, because these are defined by the basic block b2. And what, which variables are used before they are defined? So tell me, here you can see b comma c, they are used before they are defined. Remember, a is defined here in this statement. In the second statement, a is used. Remember, in this statement, a is used, but before that, a is defined. Okay, so please understand that in this basic block, I can say a is not generated, or I can say a is not used, because even though in this statement, even though you are using a, but before that, in this basic block, already a is defined. So when we find the use set of a basic block, then it will be those variables which are used before they are defined. So remember, only b comma c are used before they are defined. So the use set will be b comma c only. Very simple. What about b3? Let's find for b3 also. Which variables killed, which variables used. So you can see c is killed, a, b are used. Okay, and you can see this b4. For the basic block b4, which variables are killed, which variables are used. You can see ad, these are killed, these variables are killed. And you can see which variables are used. You can see that a is used before it is defined. Notice, in this instruction, in this statement, a is used also, a is defined also. But remember, first we use a, then we calculate a plus b, then we assign a. So remember, in this basic block, this a is used before it is defined. Okay, so yes, so a is used. What else? B is also used before it is defined. C is also used before it is defined. Okay, so A, B, C. That's it. Very simple. I hope you understood. And this is all we need. Now let's make the arrows. You can see these are the arrows, or I can say these are the edges. Okay, you can see these are the edges. And there is one more edge from B4 to B1. Now, one more thing I want to tell you. See, here you can see from B4 to B1, this edge is there. But I always recommend you that you make the edge from the end to the beginning, something like this. Okay, are you getting my point? See, in this diagram, they are drawing like this. They are drawing like this, but you already know what it means, because in a basic block, this is the exit point and this is the entry point. So I can say actually this arrow is like this. Yes or no? This edge is like this from the end of B4 to the beginning of B1. So you also make like this. Okay, don't make like this. Don't make like this. Okay, don't make like this. What you do, always, always, always make like this. Okay, I will tell you why. You will see. This we do so that we don't get confused, so that we don't make mistake. Okay, now you can see that for this basic block, let me number them B2, B3, and B4. Okay, now you can notice that for this B4, there is this outgoing edge and this outgoing edge. There are two outgoing edges for B4. Yes or no? On this outgoing edge, which variables are alive? A. And tell me, on this outgoing edge, which variables are alive? You can notice for this basic block B4, there are two outgoing edges. Notice, there are two outgoing edges. You can see one outgoing edge is here and another outgoing edge is here. Okay, from the B4 point of view. So you can see on this outgoing edge, here you can notice that variable A is alive. Okay, tell me, on this outgoing edge, which variables are alive? That is initially phi. Yes or no? I already told you that initially, for every basic block, the in of every basic block, we assume that is phi. When you have CFG with loop, then we initialize the in of every basic block with phi. Okay, this is what we do. So remember one thing, that from this basic block B4 point of view, on one edge, on one outgoing edge, this variable A is alive. On the other outgoing edge, no variable is alive. Okay, now let's start. Let's start our liveness analysis now. So we will go in the reverse direction. Let's go in the reverse direction. You tell me what will be out of B4. Tell me what will be out of B4. We are doing the first pass first. You just tell me what will be the out of B4. Okay, here I am writing the information about first pass. Everything that we will compute, I will write one by one. So first we are finding out of B4. How to do that? Remember, for B4, how many successors are there? From B4 point of view, how many successors are there? There are two successors. This outgoing is, this outgoing is. Now, did you understand why I told you to not put the age like this? Because if you do like this, then this successor you will not be able to see, and maybe you will make mistake, maybe you will get confused. Okay, maybe you will not consider this successor, but actually there are two successor. Okay, yes or no? From the B4 point of view, basically there are two outgoing edges from the B4 point of view. Okay, you can see on this edge, the set of variables that are alive, that is 5. Okay, and on this edge, the set of variables that are alive, that is A. So tell me, when a basic block has two successor, or I can say multiple outgoing edges, then how to find this out of B4? That will be union. Okay, so out of B4, that will be union. You will take union of A with empty set. So yes, that will become A. So ultimately, you will get A only. But I hope you understood the point that you need to take the union of these two. Okay, that is what you need to do. So finally, you will get A, that is fine. So we got out of B4 equal to A. Okay, now you tell me what will be in of B4. After finding out of B4, now we need to find what is in of B4. See, I'm writing in the order we are doing. Okay, the computation we are doing in the order, in the same order I'm writing also here, so that you can easily understand from the annotated notes, like in which order we are doing things. So you can see what will be in of B4. You already know the formula. What we will do? From out of B4, first you will kill. You remove kill of B4. And then you generate. Then you take union with gen of B4. Okay, so tell me what it will become. You can see from this A, first you kill AD. So A will be killed. First you kill AD, then you generate ABC. So remember, from this A, first you kill AD, so A will be gone. Now you generate ABC, so finally we will get ABC. Okay, yes or no? So I can say that here ABC will be there. ABC. Very simple. So we got in of B4. Now you tell me what will be out of B2. Let me know what will be out of B2. Here you can notice that from the B2 point of view, there is only one successor, there is only one outgoing edge from B2. For B2, there is only one successor, that is B4. So what will be out of B2? That will be same as in of B4. In of B4, we have already found, that is ABC. Very simple. So here also we got ABC. Okay, very easy. Take your copy pen. I am also solving it. You also solve. Step by step we are going. And here you can see I am also writing the things that we are doing. So you tell me here, what will be out of B3? Because we are, remember, we are going in the reverse direction here. So after this B4, you can see we have done this out of B2. Now let's do out of B3. So tell me what will be out of B3. For this basic block B3, there is only one successor, that is B4. Only one successor, single successor. So I can say out of B3, that will be same as in of B4. So that also will be ABC. Very easy. Okay, ABC. Now let's see. Let's go in the reverse direction. Tell me what will be in of B2. Let's find in of B2. You can see in of B2, what that will be. The formula you already know. from out of B2, first you kill, okay, first you remove kill of B2, and then you union generate B2. Okay, so tell me which variables you will get. Here you can see that from this out of B2, first you kill AD. Okay, AD will be killed, means A is killed. Okay, then you generate BC. BC is already there. Okay, so finally you will get B comma C only. Very simple. So you will get B comma C. Very easy. Now you calculate what will be in of B3. Let's calculate in of B3. The same formula. From out of B3, you will remove kill of B3, then you will take union with gen of B3. Okay, so remember, from this ABC, first you kill C. C will be killed. Then you generate AB. So that will be simply AB. Okay, so that will be simply AB. Now, after that, what you will do? Now you will find out of B1. Tell me how to find out of B1. For B1, there are two successor, B2, B3. So out of B1 will be equal to union of in of the successor basic blocks. Yes or no? Okay, so remember, now we are going to find what is out of B1. So for this basic block B1, there are two successor B2, B3. So out of B1 will be equal to in of B2 union in of B3. Union of in of successor basic blocks. Okay, very simple. So you take the union of in of B2 and in of B3. So that will be BC union AB. That will be ABC. Very easy peasy. Okay. So we got ABC here. Then we will find what? Then we will find in of B1. What that will be? Now, what will be in of B1? Very easy. To find in of B1, you will take out of B1 minus kill of B1 union use of B1. Very simple. So now we are going to find, let me tell you, this first pass we are discussing. So far, the first pass we are discussing. And in the first pass, the next step is let's find in of B1. And to find the in of B1, we already know what to do. You take out of B1. From that, first you kill. First you remove kill of B1. Then you take union with use of B1. B1. Very simple. Okay. So what we will get? In of B1. In of B1. That will be from this ABC. First you kill BC. BC are gone. BC are gone. Then you generate CD. So it will be ACD. Okay. Yes or no? So finally you can see it will be ACD. Okay. So you will get ACD. Very simple. So that's it. We have done the first pass. Okay. Is this clear? We are done with the first pass. You can easily notice that for every basic block, we have outset. Also, we have inset. Yes or no? So this is the first pass result. Now the first pass is over. Now we have in comma out of all basic blocks. So first pass over. Now second pass. Okay. Now let's start the second pass. So first let me write the information that we collected from the first pass. Okay. Let me write all the information that we have collected from the first pass. Let me write that. So you can easily see that we have found from the first pass, we have found that this is ACD. Okay, let me write. You can see ACD. Then you can see here we have BC, here we have AB. Okay, here we have BC, here we have AB, And you can see here we have ABC. Okay, this is what we have, correct? Okay. And so basically, this is all information we need. When we are doing the second pass, we only need, from the first pass, we only need the in information. Okay, means the in of every basic block that we have written. Is this clear? When we start the second pass, then from the first pass, only this information we need from the first pass, that what is the in of each basic block. Okay, for each basic block, what is in, that we have written. Now let's start the second pass. Okay, so the second pass we will start again from the reverse direction, from the backward direction. Okay, so now I am going to write the second pass information. In the second pass also, what is the first thing we will do? You can see we will start from the end. So you can see, let's start from B4. Let's find what is out of B4. You can see this B4 has two outgoing edges. Please understand, this B4 has two outgoing edges. Okay, and you can see on this outgoing edge, can you tell me, on this outgoing edge only variable A is alive? And tell me on this outgoing edge which variables are alive? I am asking on this outgoing edge which variables are alive, that is ACD. Yes or no? Is this point clear? From the B4 point of view, there are two outgoing edges. On this outgoing edge, variable A is alive. On this outgoing edge, this is going to the in of B1. Yes or no? This outgoing edge, this is going to in of B1, entry point of B1. At the entry point of B1, which variables are alive? That is ACD. Okay. So remember what we are going to do? We are going to do A union in of B1. Why? What is the reason? Because B1 is successor of B4. Okay, yes or no? That means there is a edge from B4 to B1. Very simple. Okay, so you will take the union of A comma ACD. So finally what it will become? A union ACD, and that will become ACD. Okay, is this clear? So remember, out of B4, that will actually become ACD. Okay, here let me write. See, this was the result of first pass. So let me write it here, that this was result of first pass. This was the result of first pass. Okay, and in this result, for second pass, what we need? For second pass, we need in info of blocks. Okay, very simple. This in info. Very simple. Okay, so you can see now on this result of first pass, let's let's find what is the out of B4. I told you out of B4 will be union of these two. So we got the out of B4, that is ACD. Okay, we got out of B4. Now you tell me what will be in of B4. So now we will calculate in of B4. What that will be? That you already know. In of B4 means out of B4 minus kill of B4 union gen of B4. Yes or no? Okay, so tell me what that will be. Out of B4, that is ACD. From this you kill AD. AD will be killed. AD are killed. Only C is remaining. Then you generate ABC. So finally you will get ABC. Yes, that is correct. Yes or no? This ABC we will get. So you can see that we will get ABC. Let me just write the formula one time. You can see the in of B4, that will be equal to out of B4 minus kill of B4 union gen of B4, and that simply it becomes ABC. Okay, yes or no? ABC. Now notice one thing. So in of B4 that will become ABC, which is same as the first pass. Nothing is changing in the in of B4. Yes or no? When you see in of B4, nothing is changing. Okay, this is same as the result of the first pass. Okay, when we do the second pass and when we find in of B4, then also we are getting ABC, and this was already there after the first pass. So now you can see that because B2 has only one successor, from B2 point of view, nothing is changing. Do you agree with me? For B2, in the first pass also, this out of B2 was ABC. Now also out of B2 is ABC. Yes or no? So this will also not change. Similarly for B3, this will also not change. Similarly, out of B1, that will be union of in of B2 and in of B3. That will be ABC. That will also not change. And you can see from this, you will find the in of B1. That will also not change. Is this point clear? Very simple point. You can notice that only in the second pass, you can notice only out of B4 has changed. But because you can see, but notice one thing, that this out of B4 has changed, but when you cross this B4 in the reverse direction and when you find in of B4, again you are getting ABC only. Okay, so you can see in of B4 is same, in of B4 is same as the first pass. Okay, so I can say this in of B2, in of B3, out of B1, in of B1, all these things they will also not change. Okay, yes or no? That's it. So this is the result of second pass. So our second pass is over. Did you notice? Not much time we have taken. You can see after, since, I can say since in of B4 is the same as first pass, first pass in of B4. So, so the ripple effect will happen. Ripple effect we can see in B2, B3, B1. Yes or no? So you can see that carefully. Okay, carefully we are checking that yes, if this did not change, then because B2 has only one successor, that is this B4, so this will also not change, so this will also not change, so this will also not change, so this will also not change. So you can see there is a ripple effect we can see in B2, B1, B2, B3, B1. Okay, so I can say that in of B1, in of B2, in of B3 will be same as first pass. Okay, that's it. So now our second pass is over. Now we need to start the third pass. Okay, is this clear? Because I told you, until nothing changes, you need to keep making passes. But one information has changed in the second pass. In the second pass, which information has changed? That is out of B4. Yes or no? So you can notice that out of B4 changed. Out of B4 changed in second pass. Okay. So go for third pass. Okay, is this clear? Now we will go for the third pass. Is this clear? So you can see on your screen, this is the result of second pass. Okay, now we will go for the third pass. So let's see the third pass. In the third pass, you tell me, again we will go in the backward direction. Okay, now you can notice in the third pass, what is out of B4? Out of B4, you can see from the B4 point of view, there are two outgoing edges. So out of B4, that will be equal to union of these two. A comma ACD, the union of these two, because remember the in of B1 that did not change. In of B1 that is same for first pass, that is same for second pass. In of B1 did not change. So you can see this is actually ACD only, and this is A. So you will take the union of ACD comma A. Again, you will get this ACD only. So you can notice that out of B4 did not change in the third pass. Out of B4 in the third pass and in the second pass is the same. Okay, so you can see here I am writing about the third pass. In the third pass, you can notice that out of B4 that will be equal to A union in of B1, and again you can see that is A union ACD, and that is ACD. So now you can notice that this out of B4 did not change in the third pass. In third pass. Okay. And now you already know that now if you see this out of B4 did not change. So in of B4 will not change. And in of B4 is not changing. So this in of B2 will not change. In of B3 will not change. Out of B1 will not change. In of B1 will not change. So finally there is no change in the third pass. Yes or no? Okay, is this clear? So you can notice that. So now ripple effect. Okay, there will be ripple effect in B2, B3, B1. Okay, so no changes. No changes in third pass. In the third pass, no changes. So stop. So stop analysis. So stop. Okay, you got your final answer. Is this clear? That's it. So you can see this is the final answer. Okay, I hope you understood how to handle control flow graph with loops. Nothing. Remember the concept is same, but the point is that maybe multiple passes might be required. So until there is no change in the liveness information, until there is no change, you keep making the passes. Okay, you keep making the iterations. I hope you understood this problem, this example. Did you understand? Please tell me. Slowly we have seen the complete details, the complete analysis of the previous example. I hope you understood. So you can notice this was our example, the previous example. And I told you because this is a CFG with loop, here there is a loop here. So what we do, what is the first step? That is initialization of in of all the basic blocks. For every basic block, the in of every basic block we initialize with empty set. Okay, then we perform the liveness analysis in the backward direction. We keep going. First we do the first pass, then second pass, then third pass, and so on until no changes happen. When no changes happen, then you can stop. Okay, very simple. So you can see this was our previous example. And for this previous example, when you do the analysis, this will be your final answer. And this is the same answer that we got. You can notice. For B1, the in of B1 that is ACD. Out of B1 that is ABC. In of B2 that is BC. In of B3 that is AB. Okay, this is the same answer that we have got in our analysis. Okay, I hope you understood. Let's solve this question. We have a control flow graph CFG with loop. Again, you can notice there is a loop here. Like this, you can see. Okay, you can see here there is a loop like this. Okay, so this is a CFG with loop. Now we need to do the liveness analysis of this CFG with loop. Okay, so here I can say the question is do liveness analysis of this CFG with loop. Okay, very simple. So let's start the liveness analysis now. Here one thing is interesting, that is every basic block. Here you can see actually One thing I want to tell you, look at this CFG, this control flow graph. Actually here, these are not 5 basic blocks. Remember, basic block is a maximal sequence of straight line instructions. Basically, maximal sequence of instructions, maximal sequence of instructions which execute together. Okay. So remember, this is actually not 5 basic blocks. Okay, actually, if you make the basic block, let me tell you, then you cannot put these two in a basic block. Why? What is the reason? Because if you put these two in a basic block, then I told you that in a basic block, there is only one entry point, there is only one exit point. In the beginning, there is entry point, at the end, there is an exit point. So if you put these two in a basic block, then it is not a basic block because you cannot jump to this second instruction. Okay, it is not possible. So remember, yes, this is a basic block B1. Okay, and you can see what is the maximal set of instructions that will have single entry point, single exit point, and that will always execute together. That is your basic block. Basic block is a maximal sequence of instruction. Basic block has maximal set of instructions. So you can notice, actually in this question, you can notice, you can take you can take these three instructions and you can say that it is a basic block. Yes, this is a basic block. Yes, there is a self loop, but this is a basic block. You can see this is the entry point, this is the exit point. Okay, and these three instructions, they will execute together in this sequence. This is the basic block. Okay, and you can see this is another basic block, that is B3. So actually in this program there are three basic blocks. Okay, if they ask you the number of basic blocks, then that is not 5, that is actually 3. And this program, if you convert into CFG, okay, because remember, in a CFG, in a control flow graph, every vertex, every node is a basic block. Okay, so you can see, if you convert into basic block, if you convert into CFG, then notice that you will get this CFG, you will get that, okay, there will be a self loop on B2. So this will be the CFG that you will get. I hope you understood. Because in a control flow graph, every node is a basic block. And remember, what is a basic block? That is maximal sequence of instructions which will always execute together, which has a single entry point, single exit point. Okay, and they will always execute in this sequence. That is the definition of basic block. So don't forget the maximal sequence of instructions, this maximal word. Okay, so this is actually a basic block B2. So actually in this program there are three basic blocks. Okay, but this is just a side information, extra information for extra knowledge. In this question we need to do the liveness analysis, live variable analysis of this program we need to do. Okay, so either you can do basic block by basic block, or you can do statement by statement. Okay, in this question let's do statement by statement, because we have already seen how to go basic block by basic block. Many questions we have done in this lecture also, in the previous lecture also we have seen how to do liveness analysis when we go in the backward direction, basic block after basic block. Okay, in this question let's do statement after statement. So let's do statement by statement analysis. Statement by statement analysis, let's do. Okay, so let's assume that at the end nothing is alive. Okay, let's assume this is given to you. Let's assume this is given that at the end nothing is alive. And remember, if it is not given, then also we assume that at the end nothing is alive. Okay, so let's assume this is given. So you can see at the end no variable is alive. This information is given to us. Here you can see, let's number the instructions. You can see this is number 1, this is number 2, this is number 3, number 4, and number 5. So I can say that out of 5, that is empty. Okay, so let me write all the steps. So I'm writing the first pass, because this is a CFG with loop. There is a loop here. This is a CFG with loop. So let me write the first pass result. Okay, in the first pass, what we are doing, you can see the first thing that we are doing, that is we are finding out of statement 5. Okay, out of statement 5, what is that? that will be empty set. Very simple. Okay, this is actually given in the question, or if it is not given, then this is assumed by default. Very simple. Okay, now you tell me what will be in of 5. Let me know. You can see in of 5, in this statement 5, one variable we are using, and okay, we are referencing z. So here you can see that we are using z, and remember, we are not defining anything. Okay, we are not defining anything, but we are using z. So remember, because we are using z, so I can say what will be in of 5, that will be simply z. Okay, now what is the next step? Now the next step, remember, we have found that this is a z. Okay, the next step is to find what is out of 4. Can you tell me what is out of 4? Now notice one thing here. For this 4, actually there are two outgoing edges. Okay, don't forget about this outgoing edge. Yes or no? For this 4, actually there are two outgoing edges. There are two outgoing edges like this. Okay, so tell me what will be out of 4? That will be union of these two. Okay, so out of 4 actually will be what? That will be union of this z union. And one more thing, because this is a CFG with loop, so I told you that before you start the question, you initialize. Okay, before you start the solution, before you start the analysis, you always initialize. Okay, so the in of every statement you can initialize with empty. This is the initialization. Okay, is this clear? This is the initialization. Initialization, okay, for CFG with loop. So now you can see here that on this, because initially we are initializing that, okay, here there is empty. Okay, here also empty. This is what we are initializing, right? Okay, so now you tell me for this 4, what will happen? This union empty. Okay, so finally I can say it will be z only. So in the first pass, remember, this out of 4, that will be z only. Okay, this out of 4, that will be z union empty, and that will be z, because you can see on one outgoing edge there is z alive, on another outgoing edge there is nothing alive. Okay, so very simple. Now you tell me what will be in of 4. In of 4, that is very simple. That will be out of 4 minus kill, then you generate. Here also you can notice we are referencing y, we are not defining anything, we are not killing anything, so we are just referencing y, so basically we are generating y, so it will be yz. Okay, now we got our in of 4, that is basically yz we got. Then now you can see what about out of 3, what that will be? Out of 3, that will be same as in of 4, because from this instruction 3 point of view there is only one outgoing edge. Yes or no? For this instruction 3, only one outgoing edge we have. So remember, out of 3, that is same as in of 4, and that will be yz. Now let's find in of 3. Very simple. In of 3, that will be first you kill, then you generate. You can see in this statement 3 there is nothing to kill, but we generate x, so it will be xyz. Okay, very simple. Then you can see what will be, we got in of 3, what will be out of 2, what that will be? Remember, for this statement 2, there is only one outgoing edge, there is only one successor, I can say. For the statement 2, there is only one successor, so I can say out of 2, that is same as in of 3, and that is xyz. Very simple. Step by step we are going. Now we have out of 2, so what will be in of 2? That will be, first we will kill, then we will generate. You can see in this statement 2, we are only killing. We will kill Z and we are not generating anything. Okay, so it will be basically in of 2, that will be simply xy. Okay, is this clear? So I can say we got xy here. Okay, and you can see that for this in of 3, what we got? We got xyz. Okay, very simple. Now you tell me, what about out of 1? What that will be? Out of 1, out of statement 1. So you notice for this 1, how many outgoing edges are there? There is only one outgoing edge. Yes or no? So I can say that for this 1, who are the successor of 1? See, who are the successor of instruction 1? Only instruction 2 is the successor of instruction 1. But remember, who are the successor of instruction 4? Instruction 4 has successor is 5 also, successor is 2 also. Okay, the remaining, if you notice, for example, who is the successor of 2? That is 3 only. Okay, very simple. So now you can see that for the statement 1, there is only one successor. So out of 1, that is in of 2. So that again will be xy only. Now we can easily find what will be in of 1. That will be equal to, in of 1 will be equal to, from this out of 1, first you kill, then you generate. In this statement 1, we are defining xy, means we are just killing xy, we are not generating anything. So xy will be killed. Okay, so finally I can say phi, or I can say empty set will be remaining. Is this clear? Now the first pass is over. Now first pass over, because now for every statement we have in comma out. Yes or no? For every instruction we have in comma out. Okay, so the first pass is now over. Now we will start the second pass. Okay, so you tell me what are the information we got from the first pass. So let me write here the result of first pass. The result of first pass, you can notice I only need the in information for every statement. So you can see that here the in information, that is Z. Okay, you can see from here, you can see Z, here YZ, here XYZ. Okay, you can see here YZ, here XYZ, here XY, and here nothing. Okay, so this is the result of first pass. Now let's see what will happen in the second pass. Okay, after the result of first pass, now let's start the second pass. Now in the second pass, what will happen? Let me write here statement by like in a sequence what we are doing. So you can see again, already you can see that this was empty, this was already given, or by default we assumed. Okay, so you can see this was already empty. At the end, no variable is alive. Okay, now you can see, let's see for this statement 5. Here statement 1, these are the statements. You can see statement 1, statement 2, statement 3, statement 4, statement 5. Okay, so tell me about out of 5. Okay, that you already know, that is same as empty. What about in of 5? That also will be Z. Okay, nothing is changing here for 5. For the statement 5, nothing is changing. Okay, so you can see that will be Z only. Now tell me what will be out of 4. Here something will change, because remember, out of 4, notice here that for the instruction 4, there are 2 outgoing edges. Okay, on one outgoing edge you have Z. On another outgoing edge, what you have? You can see on another outgoing edge, notice one thing. This is the outgoing edge. This is going to the in of 2. Yes or no? This is going to in of 2, which is xy now. Okay, so notice one thing, that out of 4, that will be equal to in of 5 union in of 2. What is the reason? Because the successor of 4, who are the successors of 4? That is 2 comma 5. These instructions are successor of 4. Okay, so out of 4 will be equal to the union of in of all the successor. Okay, so it will be z union xy, and that will be xyz. Okay, so remember here what we will get, we will get here xyz, we will get here out of 4. Here we will get xyz. Now when you get xyz, then tell me what will be in of 4. In of 4, you can see that will be first you kill, then you generate. Here there is nothing to kill, we are only generating y, so it will be again xyz. Okay, so you can see we got in of 4, that is xyz. Okay, now what we will find after this in of 4, you can see for this instruction 3 there is only one successor. From the instruction 3 point of view, there is only one successor, there is only one outgoing edge. So I can say that out of 3, that is same as in of 4. So we got out of 3, that is also xyz. Now we can find what will be in of 3. Okay, so remember out of 3 we got, that is same as in of 4, and that is xyz. So what will be in of 3? You can see in the statement 3 we are referencing, we are generating x. Okay, so in of 3 also will be xyz. Very simple. Now, so that will be xyz. And remember now, notice one thing, this xyz did not change. And for this statement 2, there is only one successor, that is statement 3. So you can see this will also not change. And for statement 1, there is only one successor, that is statement 2. So this will also not change. Okay, so that's it. So finally, this is the result of pass 2, second pass. Okay, now you can stop. Now no further changes. Now no further changes in second pass. Okay, so what we do? Because in the second pass some changes have happened, so start third pass. Okay, now we are going to start third pass. So remember, so far what we got? What the result of second pass? We got z here, we got xyz here. The result of second pass I'm writing z, then here xyz, then xyz, here also xyz, then here xy, and here nothing. Okay, so this was the result of second pass. Now you tell me in the third pass will anything happen? Here no changes will happen. Let's look at instruction 4. This is instruction 1, 2, 3, 4, 5. Let's look at instruction 4. On this side you have z, on this side what you have? That is x comma y. Okay, so you will take the union, so you will get xyz. So this will also, basically you will get out. This out also will be xyz. Out of 4 will be xyz. Okay, we are running the third pass now. You can easily see because this statement 4 has two successor. The successor of statement 4, these are 2 comma 5. So remember out of 4, that actually will be union of these two, that will be xyz. Okay, so you can see here out of 4, here also no changes. So in of 4 will also not change. So in of 3 will also not change. In of 2 will also not change. In of 1 will also not change. So you can see that result of pass 3, that is same as result of pass 2. Yes or no? Here I can say result of pass 3 is same as result of pass 2. No changes. So you can stop. Okay, is this clear? So stop. Okay, that's it. So your final answer will be what? You can see this is on your screen. This is the final answer. Okay, for every instruction I have written what is the out and what is the in for every instruction. This is the complete analysis of this question. I hope you understood. Okay, so you can see this will be the answer, final answer. One more thing, let me tell you, if you do not make multiple passes, if you only make one pass, then this wrong answer you might get. Okay, so remember, this answer you will get if you only make one pass. If we only make one pass, this is the result we will get. Okay, but remember, this is CFG with loop. But remember, this is CFG with loop may need multiple passes. Okay, is this clear? So I hope you understood. If you only make one pass, then this is the answer you will get, and this will be a wrong answer. Okay, you can see here you will get the wrong answer, but here this is the correct answer, XYZ. Okay, I hope you understood. Very simple. This question can I give you as a homework? Here you can notice we have a CFG with loop. Okay, so take this question as a homework. We have already done a lot of practice. Also, we are going to solve two gate PYQ where we have CFG with loop. Okay, so already we have seen multiple questions where we have CFG with loop, and two more gate PYQ we are going to see where we have CFG with loop. So I think this question you can take as homework. Here you have CFG with loop. Okay, and assume that initially at the end no variable is alive. Okay, assume. Now you need to do the liveness analysis. For every basic block you find what is in comma out. Very simple. Okay, so you can take this question as a homework. You can pause the video, you can solve this question, and for every basic block what is in comma out, for example basic block b1, basic block b2, b3, b4, after doing the complete liveness analysis, because remember maybe this is a CFG with loop, so maybe you need multiple passes. The point is that after doing the complete analysis, okay, you write for every basic block what is the in comma out. Very simple, that's it. This is your homework. So please try this and write your answer in the comments. Okay, now we are going to solve gate PYQs. We have seen all the concepts related to liveness analysis. We have seen live variable analysis for individual statements, for basic block, for CFG, CFG with loop, CFG without loop. Each and every concept, each and every terminology, a lot of practice we have done. So I hope you have become expert of live variable analysis. Now we are going to solve all the gate PYQs of live variable analysis. Okay. Let's solve gate 2021 question. For a statement S in a program, in the context of liveness analysis, the following set are defined. You can see use of S, that is the set of variables used in S. In of S, this is the set of variables that are alive at the entry of S. Out of S, this is the set of variables that are alive at the exit of S. So these are the standard definitions of use of S, in of S, out of S. Okay. Now the question is saying, consider a basic block that consists of two statements, S1 followed by S2. Which one of the following statements is or are correct? First of all, in this question, some terminology is given to you, and this is a standard terminology we already know. I told you that from every statement, for every statement, there are two program points. If we have a statement S, if this is some instruction or I can say statement, then remember, for every instruction, we have two program points. One immediately before this instruction, another immediately after this instruction. Yes or no? And you can notice for this instruction, you can define two set of variables. One is def s, which is also called kill s. This is basically the set of variables which are defined in this set s, in this instruction s. This is the set of variables which are defined in this instruction s. And for this instruction s, We also have another set of variables, that is use of s. This is also called gen of s. This is also called reference of s. And this is the set of variables which are used in this instruction s. And remember, for every instruction there are two program point, one immediately before the instruction, one immediately after the instruction. Very simple. So the set of variables alive at the entry point of this instruction s, or I can say the set of variables alive immediately before this instruction s, this is called in of s. And the set of variables alive immediately after this instruction, this is called out of s. So in this question, the terminology, the definition that is given to you, these are basically standard terminology. Now the question is saying that there is a basic block that consists two statement s1 followed by s2. We have a basic block. In this basic block there are two statement s1 followed by s2. There is a statement s1 which is followed by s2. So there is a statement s1 which is followed by s2. Very simple. Okay. There is a statement s1 that is immediately followed by s2. Very simple. Okay. Now the question is asking some relationship between out of s1. Basically we need to find what is out of s1. You can see in all the options there is out of s1. We need to find what is out of s1. Remember here, this s1 has only one successor, that is s2, because these statements are in a basic block. S1 s2, these are in a basic block, and s2 is after s1. I can say s1 is followed by s2. So you can see that because they are in a basic block, so we will execute these instructions in this order. First s1 will execute, then s2 will execute, yes or no. And because this is a basic block, so I can say that for this statement s1 there is only one successor, that is s2, yes or no. If you find what are the successors of s1, of statement s1, that is only s2. There is no other successor because this s1 s2, these are in a basic block. After s1 there is s2. So remember, for s1 there is only one successor, that is s2. There is no other successor. Now what will be out of s1? You can notice that for every instruction there are two program points. One is immediately before, one is immediately after. So for this s1 there is a program point here, there is a program point here, immediately before, immediately after. For this s2 there are two program points, immediately before, immediately after. But here you can notice, for s1 there is only one successor, yes or no. For s1 there is only one successor. So remember, out of s1 and in of s2 both are same. This we have already seen in our lectures also, that these two program points, they are same, because for s1 there is only one successor, that is s2. So that's it, very simple. So the answer will be, what will be out of s1? That will be same as in of s2. That's it. This is your answer. Very simple. This is the most easiest question. So you can see the answer will be out of s1 is equal to in of s2. Option A is correct. That's it. There is nothing to solve in this question. Very simple question, that there is a basic block consisting two statements, s1 followed by s2. There is s1 and there is a s2. Okay, and the question is asking what is out of s1. So you can clearly see, very easily you can see that out of s1 is same as in of s2. Okay, and if you want the complete analysis of this question, then I already told you, because you can see for s1 there is only one successor, that is s2. So that is the reason out of s1 is same as in of s2. Okay, and because remember this is a basic block, in a basic block we have a straight flow, yes or no. So you can see that after s1 s2 will execute. For s1 there is only one successor, that is s2. So these two program points, these are basically same. So out of s1 is same as in of s2. So for this question answer will be option A. Very easy question, most easy question. Let's solve GATE 2015 question based on live variable analysis. Let me tell you, this question you can solve by two methods. We are going to solve this question by two methods. The method number one, that is, we will simply apply the definition of live variable at a program point P. In our live variable analysis lectures, the link you can find in the description, we have already seen this definition. Live variable at a program point P, a lot of practice we have done, you are already very expert of finding that at a program point P, some variable is alive or not. Okay. So this is the method one to solve this question. Just apply the definition of live variable at a program point P. There is a method two, that is, we will do the live variable analysis for this control flow graph. This is control flow graph with loops. Yes or no? There is a loop here, you can notice. Okay, so this is a CFG with loop. So we can do the complete analysis of the liveness analysis for this CFG with loop. Okay, so let's solve this question using both the methods. First, let me solve this question by the method one. That is, we will just apply the definition of live variable at a program point P. In the previous lecture, we have already seen what is the definition of live variable at a program point P. You already know the definition. A variable is live at a program point if its value may be read later before it is written. Okay, means at a program point, at any particular point, a variable is alive if its value may be read afterwards, if its value may be read later before it is written again. Okay, you can read this definition that we call a variable x live at a point P. When can I say that a variable x is live at a point P? If there is some path starting from P along which the value of x is used before redefinition. Okay, and you already know that a variable that is not live, that is dead. Okay, so very simple, just apply this definition and you can solve this question very easily. Just let me quickly tell you what is the definition of live variable at a program point P. If you are at some program point P, let's assume there is a program point and you are standing here, then remember, at this program point P, when can I say a variable v is live here? We will say that at this program point P, variable v is live if there is some path, if there is some path along which v is used. Okay, along which there is some statement where v is used, something like this. Okay, means we are using v. Okay, so you can see, let's assume this is the statement s, and in this statement s we are using v. Okay, so you can see that at this program point P, we will say variable v is alive if there is some path starting from P, if there is some path along which this variable v is used, and remember, between this point P and this statement S, where this variable v is used, between these two, on this path, here v must not be written. Okay, is this clear? So here you can notice that v is not written. Okay, in this duration, v is not written. Okay, afterwards v might be written, but the point is that starting from this program point P, there must be some path, at least one path where this v is used before it is written. Very simple. Okay, or I can say that starting from this program point P, there must be some path. On this path we find some statement where v is used, and between this point P and between this statement S, between this point P and statement S, this variable v is not written. Okay, you can see the same thing is written here. A variable v is live at point P if there is a path from P to exit that contains a statement S that uses v, and there is no definition of v on this path between P and S. Okay, there should be at least one such path. At least one such path must be there. In this situation, we will say that at this point, v is live. Okay, this is what we will say. Very simple. So this is the definition you need to apply. Very simple. Also, let me tell you one more thing. If you focus on this question is saying at a statement, live at a statement. What this statement means? When can I say live at a statement? Because if you remember, I told you that for every statement there are two program points, one immediately before that statement, one immediately after that statement. So how is it possible that some variable is live at an instruction? How is it possible? Remember, I told you that for every statement S, for every instruction S, there are two program points, one immediately before it, one immediately after it. There is no program point on an instruction. On the instruction, there is no program point. Okay. So you can find the liveness information immediately before instruction S, or you can find liveness information immediately after instruction S. This is called in of S, and this liveness information is called out of S. Okay. So you tell me what is the meaning of live at an instruction? Because in this question, they are using this word live at statement, live at some statement. They are not using the word live before statement S, live after statement S. They are using the word live at statement S. So you can see, I told you in the previous lecture that live at an instruction, this means live just before, immediately before that instruction. So please understand, if you have an instruction N, then if I say live at this instruction N, means if I say live at this instruction N, then remember that is same as live immediately before this instruction N, means this is basically same as in of N. Okay. So please understand that for this statement S also, if I say live at S, live at statement S, that will be same as live immediately before S. Okay, means that will be same as in of S. Both will be same. Okay, very simple. Now let's solve this question. So you can see, first of all, notice one thing. In this question, some paragraph is given to you. Let me tell you, this paragraph is simply the definition of live variable at a program point P. Okay, let's read this. Let's read this. See what this is saying. Here you can notice this paragraph. If you read this paragraph, you will find that this paragraph is simply the definition of live variable at a program point P. Okay, so you can focus here. The question is saying a variable X is said to be live at a statement Si. First of all, you can notice the question is saying live at a statement. And I told you, when I say live at a statement, it means immediately before statement Si. It means immediately before statement Si. Okay. So if this is your statement Si, if this is the statement Si, then basically immediately before this instruction Si. Okay, means you are standing here. Immediately before Si, you are standing. Now the question is saying a variable X is said to be live at statement Si in the program if the following three conditions hold simultaneously. What are the three conditions? There exists a statement Sj. Remember, this Sj can be same as Si because you are standing before Si. Is this point clear? You can notice the question is saying live at a statement Si, and this means immediately before Si you are standing. You are standing immediately before Si. Okay, so you can see a variable X will be live here if the following three conditions hold simultaneously. The first condition is there exists a statement Sj that uses X. So actually in this, the question is not saying that Sj and Si are different. No, the question is not saying that. Okay, so please understand, the question is not telling you that Si and Sj are different. Okay, Si may be same as Sj. Okay, Si and Sj, or I can say Sj may be same as Si, because you are standing immediately before Si. You are not standing on Si, because I told you that on an instruction there is no program point. For every instruction there are two program point, one immediately before it, one immediately after it. Okay, and when I say that a variable is live at a statement, it means immediately before that statement. So you are standing immediately before this statement Si. Okay, now the question is saying that this variable X will be live here. At this point, X is live when there is a statement Sj that uses X. Means there is some statement Sj which uses X. Okay, and you can see the question is saying there is a path from Si to Sj in the flow graph corresponding to the program. Means from Si to Sj there is some path. Okay, there is some path, and you can see this path has no intervening assignment to x, means before we use, there should be no assignment. Before we use, we should not define x. So you can see this path has no intervening assignment to x, including at si and sj, means before you use, there should be no assignment. Okay, so I can say on this path, I can say there is no assignment, there is no assignment before we use x, before we use x. Okay, this is what the question is saying. Now let me ask you one question here. You tell me, this type of situation is possible or not? Will you allow this type of situation that in si, let's assume that x is equal to x plus y. Okay, and remember, you are standing here, you are standing immediately before si, and I want to check if this type of situation is there. Now you tell me, will we say x is live or not at this point? At this point, what you will say? Will you say x is live or not? Yes, x is live. Yes, x is live. Why? What is the reason? See, you might be thinking, sir, this third statement is saying that there is no intervening assignment to x, including at si and sj. At si and at sj, there should be no assignment. No, please understand that assignment might be there at si, at sj, assignment might be there, but before the assignment, you must use. This is the only point, that we must use before the assignment. Assignment should not happen before the use. Before the assignment, use must happen. And you already know that this type of statement, when you have x equal to x plus y, here we are assigning to x, here we are using x. What happens first? Use happens first. Yes or no? Because remember, first you will use x, then you will calculate x plus y, then you will write to x. So actually, in this statement, please understand, we already know that in this statement, first we use x, okay, then we assign x, then we assign to x. So please understand that if you have this type of statement, then also this definition is fine, this definition will work, because before we assign, there is a use of x. Okay, so that is the reason x is alive. So I hope you understood this definition. Basically, this definition that is given to you, this is the standard definition of live variable at a program point p. Okay, so these two are basically same. Okay, so the first paragraph that is given to you in this question, this whole paragraph, this is just a standard definition of live variable at a program point p. Okay, now let's solve this question. Now let's apply the method number one. Method number one is, we will simply apply the definition of live variable at a program point p. Okay, here you can see the question is asking the variables which are live both at statement in basic block 2 and at the statement in basic block 3 of the above control flow graph. The question is asking which variables are live at the statement in basic block 2 and also at the statement in basic block 3. And remember one more thing, when I say at the statement, it means immediately before that statement. This I already told you, so don't make a mistake. When we say at the statement, it is same as immediately before that statement. Immediately before statement. Okay, so remember where you are standing. You are standing here immediately before this statement, you are standing, and here also you are standing here immediately before this statement. Okay, so we need to find like which variables are live here also and here also. Okay, basically which variables are live here also, here also. Okay, so basically the common variables we need to find, I can say the intersection, we need to find the set of variables which are alive here, the set of variables which are alive here, we need to find their intersection. Okay, so those variables we need to find which are live at both these points. Okay, very simple. So this is what we need to find. Now we can easily see. So remember, you are standing here. Okay, so please understand, you are standing here immediately before this statement. Also, you are standing here immediately before this statement. Okay, now one by one I will ask you, and you tell me. We are just going to use the definition of live variable at a program point. Okay, so let me take all the variables. Like you can see in the options, we have PSU, R, U, Q, V. Okay, basically all the variables. Okay, let's check one by one. Now let's check with P. What about P? I am going to check all the variables one by one. Let's start with V. Okay, check variable V. So let's check variable V. Tell me, when you are standing here, starting from this point, this is your point P. Please understand, this is your point P. Now tell me, when you start from this, you are starting from here. Is there any path where V will be used before it is defined? You can notice no. Please understand that you are standing immediately before this instruction. Basically, you are standing here. Okay, you are standing basically here. Now, immediately you will see that V is written. So, all the paths, if you consider, once I start from point P, if I consider all the points, if I consider all the path, if I consider starting from here, if I consider all the path, then you can notice that in all the path, first, initially, immediately we are defining V. So we are not using V before we are defining it. Yes or no? So we check the variable V. Here I can say that V is dead. And what is the reason for V being dead? That is very simple. You can see that when I start from point P, immediately you can see the first instruction that I encounter that has definition of V. And you can see we are not using V. Okay. So you can see, I can say that at this point, V is dead. And remember, the question is asking which variables are alive both here and here. So already we know that this variable V is dead at this point. So definitely any option which contains V, that we can eliminate. Yes or no? So you can see option D eliminated. Very easy peasy. I hope you understood. Option D eliminated. Isn't it easy? Very easily you can eliminate the option D. You don't even have to check the liveness analysis of this graph, of this CFG. You don't have to do the complete analysis of this CFG. Okay, you can simply see that this variable V at this program point P, this is dead. Okay, what about this program point? Okay, let's call this point P dash. Tell me, what about this point P dash? What can I say about V? Here V is alive or dead? Now I'm starting from P dash. When you start from P dash, is there any path where V is used before it is defined? Yes. When I start from this point, you can see first I will execute this instruction. Here there is no V. Then I will execute this instruction. Okay, first this. Then you can see we will execute this. Here V is used. Okay, so remember, here actually V is alive. But you can see at this point P, V is dead. And the question is asking which variables are alive both at these points. Okay, so I can say option D is eliminated because it contains V. Now what I can check? Which variable should I check? Three options are remaining. Let me check variable R. Okay, because variable P, variable R, these you can check. So let me check variable R. Okay, let's check. So again, you can see I am standing here. This is the point P. This is immediately before statement 2. And you can see this is point P dash. Okay. So you tell me, when I start from point P, is there any path where variable R is used before it is defined? Yes, immediately R is used before it is defined. Yes or no? So at point P, R is live. R is alive, or I can say R is live. Very simple, because immediately we are using R when I start from point P. What about P dash? When I start from point P dash, is there any path where we are using variable R? So you can see we will start from here. Okay, here there is no R. Then next instruction, here we are using R. Yes, yes, here we are using R. So at this point P dash also R is alive. So remember, R is alive at both these points. Okay, so definitely your answer must contain R. Okay, yes or no? So I can say your option must contain R. So option A is gone. Now only two options are remaining. So which variable should I check next? Only variable S I should check. Do you agree with me? Only variable S I should check because only two options are remaining now. So now we will check this variable S. Only variable S we should check now. That will eliminate one of the options. Okay, one of the remaining options will be eliminated. So let's check option S, this variable S. So you can see this is the point P, this is the point P dash. Okay, now just tell me a simple point. If I start from P, is there any path where variable S will be used before it is defined? You can see you are starting from here. First instruction is this. Here there is no S. Then the next instruction is this. Here there is no S. Then you can see this is the outgoing edge. You will go on this outgoing edge. Now the next instruction is this. There is no S. Now the next instruction is this, and the S is defined. So you can notice that before using X, actually here we use S, but before that S is defined. Yes or no? So you can notice at point P, S is dead. S is dead. That's it. Did you understand? See, when you start from point P, is there any path where variable S is used before it is defined? You can see when I start from P, first I will execute this instruction, then this is the only way. Okay, then I will execute this instruction, then after that, this is the only way. Okay, I will go to the starting of 1. Okay, remember, this arrow means at the beginning of basic block 1. So this instruction I will execute, there is no S. Then this instruction here we are defining S. So before using S, we are defining S. So S is dead here. Okay, because S is dead, so I can say that this option B is also eliminated. The answer will be automatically option C. But of course, we will check R comma U, we will check for complete analysis purpose. But did you understand that this variable S, this is dead at point P? What about point P dash? If I start from point P dash, is there any path where variable S will be used before it is defined? Yes. Immediately you can see, immediately S is used. We are using S immediately. So I can say at point P dash, S is actually live. But the question is asking those variables which are alive at point P and P dash at both the points. Okay. So very simple. So we got the answer. Remember, we got our answer, that is option C. But let's check R comma U also, just for sake of completeness. R comma U we need to check. R we have already checked. Okay. So you can see we have already checked R. Now let's check only U. So this variable U, let's check. You can notice this is our point P. This is our point P dash. Okay. So tell me, at point P, what can you say about variable U? Is there any path where variable U is used before it is defined? You can see yes, immediately variable U is used before it is defined. So U is live. Very simple. Okay. So remember, variable U is live. Okay. What about point P dash? Here you can see, is there any path starting from P dash? You start from P dash. Is there any path where U is used before it is defined? Yes, immediately U is used. So here also U is alive. So U is alive at both point P and P dash. So definitely your answer must contain U. Okay, so finally I can say the answer is option C. I hope you understood. The remaining variables also you can check if you want. For example, let's check variable P. We have checked VRSU. What about P? Let's check P just for practice purpose. variable P, let's check. So tell me about point P. Okay, let's call it point T, because now we are checking the variable P. So let's call it point T and let's call it point T dash. Okay, so tell me, when I start from point T, starting from point T, is there any path where variable P will be used before it is defined? You can see when I start from here, first this instruction will be executed, there is no P, then this is the only way, then this instruction will be executed, there is no P, then this is the only way, then this instruction will be executed, and here P is defined. So remember, before we use P, actually P is defined. So I can say at this point T, this P is dead. So you can notice that any option containing P will be eliminated. So option A will be eliminated. Very simple. I hope you understood. So we have checked for P at point T. What about point T dash? When I start from T dash, is there any path where this variable P will be used before it is defined? So you can see that when I start from here, first this instruction will be executed. There is no P. Then this is the only path. This instruction will be executed. There is no P. Then this is the only path. Then this instruction will be executed, and here you can see P is defined before it is used. So you can easily see that here also P is dead. P is dead at both these points T comma T dash. Very simple. So all the variables I think we have checked. P, S, U, R. The variable Q we did not check. Okay, this is the last variable. Let's check for sake of practice only. So let's check variable Q. Pause the video. Check for variable Q at these 2 points, at point T and T dash. Write your answer in the comments and then you play this video. Try this. So now let's see. Here you can see. What about point T? When I start from point T, is there any path where variable Q will be used before it is defined? You can see when I start from point T, then first I'm starting from here. First this instruction will be executed. Here there is no Q. Then there is no way. Here this is the way. I can say this is the only way. This is the only way. Here you can see that Q is actually defined. So remember, before Q is used, Q is actually defined. So here I can say Q dead. Okay, what about this point T dash? When I start from point T dash, then is there any path where Q is used before it is defined? See, I'm starting from here. So the first instruction that I will execute, that is this. And here itself, Q is defined. Q is not used. Basically, the first instruction, when I start from T dash, the first instruction itself defines Q and there is no use of Q here. So I can say that here also Q is dead. So at both these points T comma T dash, this variable Q is dead. That's it. So this is the analysis. This is the solution of this GATE 2015 question. And remember, in this solution, we are not doing the live variable analysis of this CFG. Of course, there is a method number 2, that is we can do the liveness analysis of this CFG which has loop. This has a loop, yes or no? So we can do the complete analysis of this CFG. But I hope you understood that using the method 1, you can get answer very quickly. Yes or no? You only have to focus on these 2 program points. At this point, you just have to focus and you have to find which variables are alive both at these points. Okay, just you have to apply the definition of live variable at a program point P. That's it. So I hope you understood the first method, and that is the method you should apply in the GATE exam. You don't have to do the complete analysis of the CFG. Now for sake of practice, I will also give you the solution of using method 2, means I will do the complete analysis of this CFG. But in the GATE exam, you should apply the method number 1. I hope you loved the method number 1. Please put a comment if you loved the method number 1. Now let's see the method number 2, that is we will do the complete liveness analysis of the CFG, and this CFG has a loop. Okay, very simple. I already told you that when we do liveness analysis of CFG without loop, then we will go in the backward direction. A single pass is enough. But when we do the liveness analysis of CFG with loop, then we will go in the backward direction. Multiple passes might be required. It might be possible that we need to do multiple passes until no changes happen. Also, I told you that when you have CFG with loop, then the first step is that you initialize for each basic block in of basic block equal to empty set. Okay, so this is the initialization. This is the first step when we do the liveness analysis of CFG with loop. Initialize all the basic blocks to have in of b equal to empty. Also, I told you one tip. This tip is that we will go in the backward direction, that is fine, but we don't have to go statement by statement. Instead of going statement by statement, we will go in the backward direction, basic block after basic block. Basically, for the entire basic block, we will find what is the use, comma, what is the def. These set of variables we will find for the entire basic block. Then the entire basic block we will treat as a single statement, like we have done in our lectures. A lot of practice we have already done in our lectures. The link I will provide you in the description. You can check it out. Okay. Now, so this is our CFG with loop. Let's start the analysis. So let's see the step number 1. For every basic block, the in of every basic block we will initialize by empty set. Okay. This is the initialization. So this is the step number 1. Initialization of in of b with empty set. Okay, this is the step number 1 when we have CFG with loop. Okay. Also remember one more thing, that in this question it is not given that at the end, at the exit, which variables are alive. Okay, at the exit, because here let's assume that here you have exit, means from this basic block let's assume there is a exit. Okay, this is the exit node in the CFG, let's assume. Okay, now remember in this question it is not given that at the exit node which variables are alive. So when it is not given, then I told you that you assume that no variable is alive. Okay, so at the exit node we have empty set. That's it, very simple. Okay, now remember there are two outgoing edges from the basic block 4. From the basic block 4 you can see this outgoing edge is also there and this outgoing edge is also there. Okay, very simple. Now what we will do, the next step is what I told you, that you notice one thing, in this basic block there are 3 statements. So when you go in the backward direction, will you go statement by statement, all the 3 statement one by one will you do? There is no need, because what you can do, you can simply find the def and use information for every basic block, and we only need that. Okay, so remember for this basic block b1, let's find, let me call this, yeah, this numbering is already given. You can see this is b1, this is b2, this is b3, and this is b4. So remember for the basic block b1, tell me what is the use and what is the kill. This information we need, means which variables are killed. Kill means define, kill is same as def is same as kill. Okay, and you can see which variables are used, that is same as gen, which variables are generated. Okay, so you can see in this basic block b1, psu, these are assigned, or I can say these are defined, or these are killed. So remember psu, very simple. And which variables are used before they are defined. In a basic block, when we find the use set, then we basically find those variables which are used before they are defined. So you can see that this q comma r, they are used before they are defined, q comma r. Next you can see p is used here, but before that it is defined. So I can say overall in this basic block b1, p is not generated, or I can say p is not used. Okay, so qr is there. Then you can see what about s, here s is used, but before that s is defined. So s is used after definition, means s is not used before definition. So I can say overall that in this basic block b1 we are not using s, or I can say s is not generated. Yes, v is used before it is defined. Okay, so that's it. This is the kill and use set of basic block b1. We only need this. We don't care about the 3 statement, 10 statement. This basic block can have any number of statement, we don't care about it. Okay, we only care about kill comma use information. Let's see for the basic block b2. For the basic block b2 we have kill comma use. So which variables are killed? means defined. You can see variable v is defined, and which variables are used means generated, r comma u. So you can see here v and here r comma u. Next, there is basic block b3. Okay, in this b3, which variables are killed means defined, which variables are used means generated. So you can see this q is defined, q is killed, and su, these are used. Okay, q here, su here. Very simple. What about this basic block b4? This basic block b4, here which variables are killed and which variables are used? You can see variable q is killed, and variable v comma r, they are used or generated. Okay, v comma r. That's it. Now, what are the edges? You can see these are the edges. Let me make the edges. Okay, and notice one thing. There is a edge from b4 to b1. There is a edge like this. Okay, very simple. That's it. And also remember, initially we are assuming that at the end, at the exit, no variable is alive. Very simple. And what is the initialization? I told you the step number one, that is we initialize the in of all the basic blocks with empty set. Okay, so I can say in of b1, that is empty, in of b2 empty, in of b3 empty, in of b4 empty. Okay, that's it. I hope you understood. Very simple. Now what I'm going to do, because this is a CFG with loop, so it might be possible that we may need to do multiple passes. So I will tell you the information about every pass. Okay, so first let me write about the first pass. So in the first pass, what we are going to do, we will do the liveness analysis in the backward direction. So first what we will do, we will find what is out of b4. Yes or no, we need to find what is out of b4. So let's quickly find out of b4. What will be out of b4? Remember, for this b4 there are two outgoing edges, so we need to take the union. Yes or no? But you can see on both the outgoing edges, on this outgoing edge also, the set of live variables is empty set. And you can see on this outgoing edge also, on this outgoing edge, let's see, on this outgoing edge we have in of b1. Initially we assume that in of b1 is empty set, so I can say that on both the outgoing edges the set of live variables is empty set. So I can say out of b4, that will be like empty set, union empty set, overall that will be empty set. So out of b4, that is empty set. Okay, so we found out of b4, that is empty set. Now let's find what is in of b4. In of b4, for that we can apply our formula. I told you to find the in of b4, what you will do, first you will kill, then you will generate. Yes or no? So it is very simple, that out of b4, from that you remove kill of b4, and then you take the union with gen of b4. Okay, first you kill, then you generate. Very simple. So you can see that from this phi, this is the out of b4, from this phi you remove kill, means from this phi you remove q, phi minus q, that is equal to phi, then you generate, that is vr. So finally what you will get, you will get vr. Okay, is this clear? So notice that this, remember, this photo is after initialization. This photo is after initialization. This is the initial photo, and now this is the photo for first pass. Here I will write the first pass. So you can see in the first pass, what will be in of b4? That will be v comma r. Okay, this will be in of b4. So finally I can say in of b4, that is v comma r. That's it. Okay, now after this in of b4, what we need to find? We need to find out of b2 and out of b3. Notice that for this b2 there is only one successor, that is b4. So out of b2 will be same as in of b4. Yes or no? So now we will find what is out of b2. and out of B2 that will be same as in of B4. The reason is simple, because for B2 there is only one successor, that is B4. There is only one successor for B2. So out of B2 that will be same as in of B4, and that is VR. Similarly, we will find out of B3. You can see for this B3 also there is only one outgoing edge, or I can say there is only one successor for B3, that is B4. So out of B3 that will be in of B4, that is also VR. That's it. So now remember, we have this VR here, and here also we have VR. Now you tell me what will be in of B2? In of B2, we have out of B2. From this, first you kill, then you generate. So remember, first you kill this V will be killed, then you generate RU. Okay, so what we will get? We will get finally RU we will get. Okay, so this in of B2 we will get RU. Simple. Okay, so we will get RU. What about in of B3? In of B3, that is very simple. First you kill from this out of B3, first you kill this Q. There is no Q, so don't worry. Now just generate this SU. So finally you will get SUVR. Okay, so we got in of B3. What we got? In of B3 is SUVR. SUVR. Okay. What next? Now you can notice we need to find what is out of B1. Yes or no? So let's find now out of B1. What that will be? You can see for this basic block B1 there are two successor, B2, B3. There are two outgoing edges, there are two successor, B2, B3. So out of B1 will be the union of in of all the successor blocks. Okay, so I can say it will be union of in of all the successor blocks, means in of B2 union in of B3. So overall what you will get? You can take the union of these two. RU union SUVR. Okay, so basically it will be SUVR only. That's it. So we got this out of B1, that is SUVR. Now what will be in of B1? In of B1, what that will be? That is very simple. First you kill this PSU, you kill. Okay, so S comma U, these will be killed. Okay, SU, these are killed. Now you generate QRV VR. So finally you will get QRV. Okay, yes or no? So remember what you are going to get? QRV. This is what you are going to get. Okay, from this SUVR, first you kill PSU. Okay, so this will be killed. Now VR union QRV. So that will be simply QRV. Okay, so finally remember here we will get QRV. That's it. So this is the result of the first pass. Remember, so far we have only done the so far only first pass we have done. Now the first pass is over, because for each basic block we have found in comma out. Okay, so now first pass over. When the first pass is over, then what you do? Now you start the second pass. Okay, now I will do quickly. The first pass I have done in a very detailed way. Okay, now let me do this second pass very quickly. First, let me write the information from the first pass. From the first pass, for each basic block, what is the in information that we got? Okay, we only care about the in information. So you can see here we have RU. Okay, notice here we have RU. Then you can see here we have SUVR. Here we have SUVR. Next, you can notice here we have VR. Next, here we have QRV. Okay, here we have QRV. So this is what we need. That's it. Now let's see. So this is the in information of every basic block, and this is actually the result of first pass. I have just written the result of first pass I have written. Now we will start the second pass. Okay, this is the result of first pass. Now let's start the second pass. Okay, so in the second pass, again, we will go in the backward direction. But now you can notice for the basic block B4, there are two outgoing edges. Don't forget about this outgoing edge. There are two outgoing edges. And you can see that here you have QRV, because please understand, from B4 there is outgoing edge to B1. Okay, to the entry point of B1. From the exit of B4 to the entry point of B1. So I can say on this edge, which liveness information we have, that is QRV. Okay, now notice one thing, that from this B4 there are two outgoing edges. So what we will do, we will take the union. Yes or no? When I take the union, I will get QRV. Here I will get QRV. Then what will be in of B4? Out of B4, that is QRV. Okay, so let me write here. In the second pass, the first step, what is that? First we are finding out of B4, and out of B4, that will be what? That will be this union in of B1. Okay, empty union in of B1. Why empty? Because of this. Because we are assuming that at the exit there is nothing live, there is no variable alive. Okay, so you can see that in of B1, that is QRV. So finally it will be QRV. This is the out of B4. Now let's find the in of B4. For the in of B4, what we will do? From this out of B4, first we will kill, then we will generate. So you can see that from this QRV, first you kill this Q. This Q will be killed. Then this VR will be generated. So it will be VR only. Yes or no? So you can notice that in of B4, that will be VR only. And now notice one thing. This in of B4 did not change. Notice simple observation you make, that this did not change in the second pass. In the first pass, this is unchanged. Yes or no? This is same in second pass and first pass. Second pass and first pass. So this did not change in the second pass also. If this did not change, then you can see that for the basic block B2, there is only one successor, that is B4. So out of B2, that will also not change. Out of B2 will be same as in of B4. If out of B2 is not changing, means out of B2, that is same as in of B4. Now you can see that if out of B2 is not changing, then in of B2 will also not change. So the same in of B2 we will get. Similarly, you can see for this basic block B3, there is only one successor, that is B4. So out of B3, that also will be in of B4. So this out of B3 will also not change. Again, we will get VR here. So this in of B3 will also not change. Now we will take the union. Okay, because for the basic block B1, there are two successor, B2 comma B3. So the out of B1, that will be union of in of the successor basic blocks. So you will take the union, that will be SUVR. Okay, so you can notice that this is also not changing in the first pass. In the second pass, this is same. So what will be in of B1? That also will not change. Okay, yes or no? So there is basically only one change in the second pass. This is the only change. QRV means this out of B4. So remember, in second pass, only one change. What is that change? That change is basically out of B4. Out of B4 changed. Nothing else changed. Okay. Now you tell me, what about third pass? Because in the second pass, something changed. So now you will go for the third pass. But you tell me, in the third pass, now we are going for the third pass. But in the third pass, nothing will change. Okay, you can see after this, now start third pass. Okay, but notice that in the third pass, nothing will change, because you can see in the third pass, this in of B1, that is still QRV. So you will start the third pass, you will go in the backward direction. But you can see in of B1, that is still QRV. So what will be out of B4? That will be union of this and this. So that will be again QRV. So can you notice that? Can you notice that? This is same in the second pass and third pass. Which one? You can see this is also same in the second pass and third pass. This is also same in the second pass and third pass. Basically, this out of B4 is also not changing. If out of B4 is not changing, then in of B4 will not change. If in of B4 is unchanged, then out of B2 will not change, out of B3 will not change. So in of B2 will not change, in of B3 will not change. So out of B1 will not change, and in of B1 will not change. So in the third pass, basically there are no changes. If there are no changes, you can stop here and you can just say this is the complete liveness analysis. Okay, you have completed. Now, what the question was asking? The question was asking that for this statement, for this basic block B2 and for this basic block B3, immediately before the basic block B2 and immediately before basic block B3, which variables are alive at both these points? The question was interested in these 2 points. Yes or no? This was our point T, and this was our point T dash. Now the question was asking the intersection, means which variables are alive at both these points. Okay, so now you can just take the intersection. So remember, for this basic block 2 and for this basic block 3, what we got? We got the set of live variables here, that is r comma u, and the set of live variables here, that is s u v r. Okay, now you can just take their intersection. So r u intersection s u v r, what you will get, that you will be r u, and this will be your answer. These are the live variables at both these points. Okay, I hope you understood. So this is the complete analysis of this GATE exam question. We have done this question, we have solved this question by 2 methods, method 1, method 2. Which method did you love the most? Which method will you apply in the GATE exam? Will you apply the second method or will you just apply the first method? Let me tell you, for this GATE 2015 question, if you apply the first method, you can get the answer within few seconds, maybe 1 minute maximum. So the question is very easy. Just apply the method 1, means just apply the definition of live variable at a program point P. That's it. Just eliminate the options and just get the answer. Okay. I hope you loved the complete analysis. Okay. Now let's move on. Let's solve GATE 2023 question based on live variable analysis. This question is similar to the previous GATE 2015 question. Here also we have CFG with loop. You can notice that there is a loop here. So this is CFG with loop. In GATE 2015, the question that we have already done in the previous question, we had CFG with loop. So for that question also we have done the complete analysis. For this question also we can do the complete analysis. Let me tell you, to solve this question there are 2 methods. The method number 1, that is we will simply apply the definition of live variable at a program point P. You can simply apply this definition and you can solve this question. Or the method 2, that is we can do the complete live variable analysis of this CFG with loop, because this is CFG with loop. Okay. From the GATE exam point of view, this method 1 you should apply because it will save a lot of time. You just have to apply the definition of live variable at a program point P. But for sake of completeness, for sake of complete analysis, I can provide you the solution with both the methods, but I can say that this method 2 you don't have to apply in the GATE exam. And in the previous GATE 2015 question also, we have seen this method 2, the complete analysis using this method 2, also the complete analysis using this method 1. Okay. Now let's see the method 1 first. To solve this question, the question is asking which one of the following choices is a correct list of set of live variables at the exit point of each basic block. So at the exit point here, 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 and here, at the exit point of each basic block, we need to find the set of live variables. Okay. So we can apply the definition of live variable at a program point P. You can see the definition of live variable at a point P. That is very simple. A variable is live at a particular program point if its value may be read later before it is written, before it is redefined. So you can see we call a variable x live at a point P if there is some path starting from P along which the value of x may be used before it is redefined. And remember, a variable that is not live, that is called dead. Very simple. So let's see in this question, we have these program points. The question is asking that at the exit of each basic block. So this is the basic block B1. Remember, for every basic block, there are two program points, one at the entry, one at the exit. In this question, they are only interested in the at the exit point of the basic block. Means at this point, okay, you are standing at this point also. At the exit of this basic block, you are standing here also. Okay, at the exit of this basic block, stand here. And at the exit of this basic block, stand here. Okay, so these are the four program points. Point let me call it point 1. Okay, I am calling it point 1. let it be let it be point 1. Let it be point 2. Okay, for every basic block there are two program points, one at the entry of the basic block, one at the exit of the basic block. Here the question is interested at the exit of the basic blocks. So let's call it point 3 and let's call it point 4. So these are the program points. Okay, now let's see. These are the options. We will check for each option. Okay, for each option, like we can eliminate some options basically. Okay, we will check for each program point at the exit of basic blocks. Okay, so here first of all, how many variables are there? You notice what are the variables that we have noticed? I, M, J, N, A. Basically I, J, M, and A. I, J, M, and A. Only 5 variables we have to check. You can see these are the variables I, J, M, and A. That's it. Okay, so remember, only these variables we have to check. The variables are I, then J, then M, then N, then A. Okay, so let's see for the point 1. Okay, one by one for each point we will see. Now first let me see for point 1. At this point 1, which variables are alive, which variables are dead? Okay, so remember, where are you standing? You are standing at point 1. Okay, so maybe what I can do, yes, so let's take this clean photo. Okay, so the variables, what are the variables? I, J, M, and A. These are the variables. One by one, each program point we will see. Okay, so let's focus only on this program point. Let's call it point 1. Okay, so tell me, for this point 1, which variables are alive here, which variables are dead here? Let me check. When you start, you are standing here, you will start from this point. Okay, so let's check. When you start here, is there any variable which will be used before it is defined? You can notice when I start from here, there is only one way I have to go here, because I am starting at the exit of B1. So there is only one way, only one outgoing edge is there. So I will go here. You can see here, I equal to I plus 1. Tell me a very simple point here. First I is defined or first I is used? You can notice here I is used also, defined also. So first what is happening? This is the instruction, I equal to I plus 1. Here, what is happening first? Use is happening first or definition is happening first? Here first use is happening, because please understand, first you will use I, then you will calculate I plus 1, then you will assign to I. Okay, so here you can notice that that first use is happening, first we use I, then we assign I. Okay, so I can say, if you start from program point 1, from point 1 if you start, then you can notice that variable I is used before it is defined. Okay, so definitely I can say what variables are live at point 1. Definitely variable I is live at point 1, because remember, starting from this point, is there any path? Is there some path? Is there at least one path where This variable is used before it is defined. Yes. Okay. Yes. Okay. What about the variable j? Let's see. Here also the same thing. Variable j is also used before it is defined. Okay. I will start from point 1. There is only one outgoing edge, so I will go here. Okay. This path I have to take. First this instruction, then this instruction. You can notice that we are using j before it is defined. Okay. Here also the same story. The same story here also. First we use j, then we define j. Okay, so here also I can say that variable j, that is also alive at point 1, because we started from point 1 and there is some path where variable j is used before it is defined. So variable j is alive at point 1. What about variable m? You start from point 1. There is only one outgoing edge, so these two instructions you will execute. After that, you can notice, if you go on this path, let's focus on variable a. If you go on this path, a is defined first. Okay, so if I go on this path, a is not used before it is defined. So if I'm checking for variable a, then I have to go this path, because if I go on this path, then variable a is defined. I want variable a to be used before it is defined. So let me go on this path. Here on this path, you can notice that variable a is used before it is defined. So you can see I'm starting from here, I'm going like this, then I can go like this, then here a is used before it is defined. On this entire path, notice, on this entire path, started from here and till here, I can find the use of a, and on this entire path, on this path, a is not defined before the use. Okay, so I can say that at this point 1, a is also alive. Okay, very simple. So I can say a is also alive. What about m comma n? Now let's focus on m comma n. So I will start from here, then I will execute these. Then if I go here, then also the same place I will reach. Okay, now from here, either I can go to exit or I can go to loop. Now you can see that if I start from point 1, I can never go to any use of m comma n. Do you agree? I am starting from point 1, but you can notice in this program here, in this part of the program, in this part of the control flow graph, there is no m comma n. To use m comma n, I have to go to b1, but there is no path to b1. If I start from exit of b1, I can never go to entry of b1. So I can say that dead variables, which are dead variables, m comma n, these are dead variables for this program point 1. Okay, so here, which are the live variables, I can say these are only I, j, a. Okay, now let's see, can we eliminate some option? At the exit of b1, I, j, a, these are alive. Okay, for b1, you can see option a, you can eliminate. I can eliminate option a, because option a is saying that at the exit of b1, no variable is alive. But actually, at the exit of b1, I can say that at the exit of b1, actually, this variable I, j, a, these variables are actually alive. So option a is gone, option b is also gone, but option c comma d are remaining. Okay, to just tell me one thing, if you want to eliminate one of the options c comma d, which basic block you will check next? You can see that what you will check next. There is no benefit in checking b3, because here also ai, oh here aj. Okay, you can either check b3, or you can check b2, or you can check b4. Any of them you can check. Okay, so let's check b2 now. We have already checked b1. Now let's check b2. Okay, so basically this is the program point, means at the exit of b2 we need to check. Let's call it point 2. Okay, let's see which variables are alive at point 2 and which variables are dead. So where are you standing? You are standing at the exit of b2. Okay, let's see. You can notice that if I start from point 2, then if I go on this path, then here a is used before it is defined. I am starting from here, I am going like this. Here a is used before it is defined. On this path, a is used before it is defined on this path. So there is some path started from point 2, starting from this point, there is some path where A is used before it is defined. So definitely I can say that A is alive at point 2. Very simple. Okay, what else? You can see if I go on this path, A is actually defined. But you can see there is at least one path where A is used before it is defined, starting from point 2. So remember, A is actually live. A is alive at point 2. Okay. What about the other variables? For example, I, you can see if I start from here, if I take this path, then I is defined before it is used. So let me take another path. If I take this path, then also I will come here where I is defined before it is used. Remember, this is constant. This is not I. Here we have a plus 1. Okay, so I is defined, but it is not used. So I can say if I start from point 2, then whatever path I take, I will be defined before it is used. So definitely I is dead. At point 2, I is dead and A is alive. Some option can be eliminate. At point 2, I is dead. So yes, option C also I can eliminate. That's it. Okay. Yes or no? Automatically I can say answer will be option D. So this question will not take a lot of time. If you apply the method number 1, just simply apply the definition of live variable at a program point P. You don't have to do the complete analysis of this CFG. It has loop. So it will take a lot of time if you do the complete analysis of this CFG with loop. Okay. You can just eliminate the options. But anyway, let me tell you, for sake of complete analysis, let me tell you for other variables also. Okay, let's check for J, variable J. I am starting from here. Now let's check variable J. I can either go like this or either I can go like this, but then I can go like this. And here you can see that this variable J will be used before it is defined. So yes, J is actually alive. Okay, yes or no? Because notice, if I start from here, if I take this path, let me take this path, I am checking for variable J, then you can see that here variable J is used before it is defined. Okay, notice one thing here. First J will be used. First we will use J, then we will define J. Okay, first we are going to use J, then we will calculate J minus 1, then we will assign to J. Okay, so very simple point. So I can say J is alive. What about M comma N? Notice one thing that in this part of CFG, there is no M comma N. And if I start from point 2, then I can never reach to the entry of B1. This M comma N are only in the entry of B1. Yes or no? So I can never reach the entry of B1. So I can say that if I start from program point 2, then I can never go to use of M comma N. So I can say M comma N are dead. Okay. One more thing you notice, you can check any exit of any basic block. Whatever basic block exit point you check, you can see that from any exit of any basic block, you can never go to the entry of B1. And if you can never go to the entry of B1, then you can never encounter M comma N. So I can say you can never find use of M comma N. If you start from exit of any basic block, you can never find use of M comma N. So I can say for every exit of every basic block, I can say M comma N are dead. Yes or no? So definitely M comma N, they are dead for all the 4 exit points of these 4 basic blocks. Okay. I hope you understood. So you can see we have done B1, B2, and now you can do B3 also. For sake of completeness, let me do B3 also. At the exit of B3 for practice sake. So basically, let's call it point 3. At point 3, which variables are live, which variables are dead? One thing you can notice, if I start from exit of B3, I can never go to the entry of B1. So I can never find use of M comma N. Okay, because whatever I do, this is the area where I will get stuck. Okay, so I can say that, and in this area there is no M comma N. So definitely I can say that if I start from this point 3, if I start, then there is no path where I can find the use of am, or I can find the use of an. Yes or no? So they are definitely dead. What next? If I start from here, there is only one outgoing edge, so I have to go here. And here you can see that we are using a before it is defined. So yes, a is alive at point 3. Okay. And you can see if I start from here, then this is the only path I have to take. And here you can see that this I is defined before it is used. So definitely I can say that I is also dead. Okay. And you can notice if I start from here, I go like this, then you can see that J is used before it is defined. So definitely J is alive. Okay, that's it. So this is for point 3. Let's see for point 4 also, means this point 4. For this point 4, what are the live variables? What are the dead variables? Okay, you can notice that if I start from here, I am standing here. If I start from here, I can never go to entry of B1. Okay, basically, whatever I do, I will basically stuck here. I will be stuck here. So I can say that, and in this area, there is no variable m comma n. So I can say variable m comma n are dead, because if I start from here, then there is no path where I can find the use of m comma n. Okay, so very simple that m comma n are dead. Okay, if I start from here, then you can see I will use I before it is defined. So I is live. I will use j before it is defined. So j is alive. What about a? If I start from here, then I can take this path, and here a is also used before it is defined. So this path is there. So definitely a is also alive. Okay, that's it. So at the point 4, I, J, A, these are live. Okay, so you can see at point 4, I, J, A are live. Okay, so this is the complete analysis of this question that we have done. So remember, this method 1 we have seen, where we are applying the definition of live variable at each program point. Okay, this definition we are using live variable at a program point P. Now there is another method, that is complete analysis of this CFG with loop. Okay, so let's see this method number 2. Remember, this method number 2 you do not have to apply in the gate exam, because this method number 1 that was beautiful, that will save a lot of time. So in the gate exam you can always apply the method number 1. And this method number 2, for this method we have done a lot of practice in this lecture already. The previous gate question, gate 2015 question, for that question also we have seen this method number 2, the complete explanation, the complete analysis we have done. Before that also we have seen this method number 2 for multiple questions, multiple standard questions. So a lot of practice we have already done for this method number 2. Also this you should not apply in the gate exam also, because method number 1 is there. So let me quickly tell you, I will not write everything, but I will quickly tell you how to apply this method number 2. Okay, so in this method number 2, we will do the liveness analysis of CFG with loop. The concept you already know. When you have CFG with loop, then we will go in the backward direction. Multiple passes might be required until no changes happen. So we will do first pass, second pass, third pass, and so on, until no changes happen in the liveness information. Okay, very simple. And remember, when you have CFG with loop, then there is a initialization. We initialize all the basic blocks with in of basic block equal to empty. Okay, so this initialization we have to do. This is the first this is the first step when we handle CFG with loop. Okay, very simple. Also, this tip you can consider, that when we handle the liveness analysis of CFG, then instead of going statement by statement, we can go basic block after basic block. For the entire basic block, we can find use comma def, and we can treat the entire basic block like a single statement. A lot of practice of this tip we have already done. Okay, so let's see here. Let me quickly tell you what is the use comma def of each basic block. Okay, let me tell you. For example, for this basic block B1, tell me what is the use and what is the def. Just tell me this point. For this basic block B1, you tell me what variables are used, what variables are defined. You can see the variables which are defined, you can see that is ija. These variables are defined, ija. And which variables are used? When I say some variable is used in this basic block, it means used before definition. So I can say, for example, m is used before defining, n is used before defining. Actually, in this basic block b1, no other variable is used. So this is the use set of b1. What about b2? What is the use set of b2? You can see in this b2, we are using I before defining, we are using j before defining. So I can say I comma j. And what is def? Def means kill, which we are defining, which variables we are killing. That is very simple, that is I comma j. Okay. Next, what about b3? In b3, we are not using any variable, the use is empty. Okay. And what is def? We are killing a, we are defining a, we are killing a. What about b4? What is the use? The use is a, we are using a. And what variable we are defining? We are defining I. Okay, that's it. And remember one thing in this question, at the exit, this information is not given that at the exit which variables are alive. So in this situation, I told you, assume that at the exit, nothing is alive. Okay, empty set you can assume. Now what we will do? Now the initialization, the first step is that we will initialize, we will assume that the in of bi for every basic block, the in of every basic block is empty set. This is what we will assume. Okay. Now you can see for this basic block b4, there are two outgoing edges. Okay, you can see there is one outgoing edge here and there is another outgoing edge here. So what will be out of b4? That will be union of these two. But here also you have empty set, and initially here also you have empty set. Initially for each basic block, the in of each basic block is empty set. So empty set union empty set, that will be empty set. So here you will get empty set. Then what will be in of b4? Notice one thing, here you got this out of b4, you got empty set union empty set. So you got empty set. Okay. Now you tell me, what about in of b4? Very simple. From this out of b4, first you kill what we are killing, I we are killing, and then you generate what we are generating, a we are generating. So it will be a. Now you can see for this b3, there is only one successor, that is b4. So out of b3, that will be a. And what will be in of b3? That is very simple. First you kill, you can see we are killing this b3, this is killing a. You can see b3 is killing a. First you kill, then you generate. b3 is not generating anything, so it will be empty set. Okay. In of b3, that is empty set. What about out of b2? Remember, for b2 there are two successor, b3 and b4. So you will take the union, empty set union this a. So that will be a only. What about in of b2? Here you can see in of b2, what that will be? From this out of b2, first you kill, then you generate. So remember, first you kill, I comma j will be killed, and then you generate I comma j will be generated. So finally here you are getting a I j. This is what you are getting. Okay, then you can see what will be out of b1. For b1 there is only one successor, that is b2. So out of b1 will be same as in of b2, that will be a I j. And what will be in of b1? You can see this b1, first you kill, this b1 is killing aij. Aij will be killed. Then this b1 is generating m comma n. M comma n will be generated. Okay, this is the first pass. Now the first pass is over. For every basic block, we have found in comma out. Okay, so the first pass is over. Now we will start the second pass. Again, we will start from the reverse direction. In the backward direction, we will start. Okay, so is there any changes? Yes, there are changes, because see, what about out of b4? Notice one thing, now we are starting the second pass, but in the second pass, already here on this edge what we have, because notice from b4 there is a edge to the entry of b2. From exit of b4 there is a edge to entry of b2. Entry of b2, that means in of b2. In of b2 is what? That is aij. So remember, at this edge now we have aij. After the first pass we have aij here. Okay, and you can see from this b4 there are two outgoing edges. So what you will do out of B4, that will be union of this empty, because here you have empty, this union Aij. Okay, so what that will be? That will be Aij. Okay, so this change has happened. Now, out of B4, that is equal to Aij. Now you tell me what will be in of B4. First you kill I. First I will be killed. Then A will be generated. Okay, so you can see I will be killed, A will be generated. So basically that is A comma J. Okay, you got A comma J. Now you can see for this B3, there is only one successor, that is B4. So out of B3 will be same as in of B4. Out of B3, that will be same as in of B4. So that is also A comma J. Okay, next you can see what will be in of B3. Here you can see first you will kill A and nothing is generated by the B3. So I can say it will be J. Okay, now you can see we have in of B3, we have in of B4. So what will be out of B2? That will be union, because for this B2 there are two successor B3 comma B4. So out of B2 that will be union of successor, union of in of successor. Yes or no? So you can see this J comma Aij, sorry, this J comma Aj. Okay, so you will take the union of J comma Aj, that will be Aj only. Okay, after that, remember one thing, that for B2 there are two successor B3 B4. So the out of B2 will be union of in of all the successor blocks. So J union Aj, that will be Aj. Now what will be in of B2? Very simple. First you kill Ij. First Ij will be killed. Then you generate Ij. So that will be Iaj. So that will be as it is, Iaj. Now you can see in of B2, that is same. So out of B1 also will be same, because for B1 there is only one successor. So out of B1 will be same as in of B2. So you can see there is no change in the out of B1. So there will be no change in the in of B1 also. In of B1 will be M comma N. This is your second pass. Now let's see the third pass. Remember, we have seen the first pass. We have seen the second pass. And now we will see the third pass. Okay. In the third pass, again, we will start from the end. Okay. So you can see what about this B4? Notice one thing. From this B4, there are two outgoing edges. Here you have empty live variables, means empty set. Live variables is empty set. And you can see there is another outgoing edge. This outgoing edge is going to entry of B2. What is in of B2? That is unchanged. That is Aij. So remember, that is still Aij. So again, out of B4 will be what? That is empty set union Aij. That will be Aij. So this out of B4 is unchanged. If out of B4 is unchanged, then in of B4 will be unchanged. This in of B4, this will be unchanged. If in of B4 is unchanged, then out of B3 will be unchanged. In of B3 will be unchanged. In of B3 and in of B4 are unchanged. So out of B2 will be unchanged. In of B2 will be unchanged. Out of B1 will be unchanged. In of B1 will be unchanged. So remember, in the third pass, nothing changed. Okay, this is a third pass is same. In third pass, nothing changed, I can say. In third pass, nothing changed. Okay, so now you can stop and you can write the answer. The question was asking the set of live variables at the exit of each basic block. Okay, so you can now you can easily answer at the exit, at the exit of at the exit of B1. What you have? You can notice at the exit of B1 you have Aij. Aij. At the exit of B2, what you have? At the exit of B2 you have Aj. You can see Aj. At the exit of B3, what you have? That is also Aj. And at the exit of B4, what you have? That is Aij. Okay, so this is your method number 2. I hope you understood. So we have done the complete analysis of all the gate PYQs. We have seen liveness analysis, live variable analysis, liveness analysis for individual statement, for basic block, for control flow graph, without loop, with loop. We have seen all the gate PYQs with multiple methods. Okay, either we can apply the definition of live variable at a program point, or we can do the complete analysis of the CFG of the control flow graph. I hope you loved each and every question, the complete analysis, and I hope you understood each and everything. Okay. So we have completed liveness analysis, the complete concept we have seen. Now there are two important applications of this live variable analysis, or I can say there are two important optimizations. These are dead code elimination and register allocation. So in the next lecture, we will study these applications and all the gate PYQs based on these two applications. Those also we will solve. Okay. Thank you everyone. Please like this session and please share your feedback in the comments. Thank you.